Hello everyone, a warm welcome to you all. I'm Tanya, your host for today, and I'm convener at the Aeromodelling Club IIT Bombay. Today, the Aeromodelling Club of IIT Bombay present to you Dronexel, a beginner-friendly workshop to kickstart your journey into air robotics. We will cover everything from drone sizing basic to tools like eCalc and systems like Pixhawk and INAV. You will hear from my co-convener Anamika, Tessa, Shuddesh, and Ayush as we go through each part of the session. Let's get started. First up, Anamika will take us through drone sizing.
Hello everyone. Is my screen visible to everyone? Okay. I am Anamika Garg from Engineering Physics Department. I'm a convener from Aeromodelling Club, and I'll be taking you towards drone sizing. So what exactly is drone sizing? So drone sizing is nothing but choosing right components for your drone, be it propeller, be it battery, be it frame, whatever you need for your drone. What will you choose? That depends on the drone sizing. And so how will you choose what components do you need for the drone? For that, you need to define the purpose of your drone. So whatever problem statement of your drone is, that will define whatever you will use for your drone. So the payload capacity, what is the range for your vehicle? Do you want to for speeding? So everything, all these things depends. So now let's dive into it. So the two major type of drones are quadcopter and hexacopter. So main difference between these are that quadcopters are easier to make, whereas hexacopters are a little complex. Plus they have a little more weight, so more load on battery, which means smaller flight time. Whereas quadcopters have longer flight times when compared to hexacopters. One thing here is that quadcopters have limited payload capacity, whereas hexacopters give you a little more payload capacity. So what you're choosing, whether it is hexacopter or a quadcopter, depends on your purpose. Moving on, the first thing you'll choose is drone frame. So when you'll go and try to search up drone frames, you will find the names like S400, S500, Q550. So what does this name suggest? So the last three digits like 550, 400. This is the drone frame length. Frame length is this diagonal length. So if it is 500 means 500 is the drone frame length. And how will you choose the frame length? So the thing is, you don't want to waste any space on the drone frame. So whatever your drone frame is rated for, the propeller. So in case this frame is rated for 10-inch propeller, you don't want to attach 8-inch propeller because then you'll be wasting the space. So according to the propeller size, you will choose the drone frame so that you don't waste any space. Moving on to propellers. So propellers have two main properties. First is diameter and second is pitch. So let's see both of them. So first is diameter. So either you'll choose the larger props or the smaller props. So how will you decide what you want? So when you see the larger props, they have more area, which means they provide more thrust, more power. But with large area, with more power comes less responsiveness. Whereas smaller props, they do provide less thrust, but they are more responsive. So if you want your drone to be very agile, you'd want to use smaller props. Prop diameters, they can range from 3-inch to 16-inch or more, and you can choose according to your problem statement. And if you want to dive in more about propellers, you can go through this link. Now the next thing about the propellers, that is pitch. So what exactly is pitch? So you have read about helices in 12th grade. So from there you have idea what exactly pitch is. It is similar here also. So pitch is basically how much air the propeller moves when it moves one complete rotation. So you can either go for high pitch propellers or low pitch propellers. But how will you decide? So in general, high pitch propellers so you can imagine when you see the planes, the wings have angle of attack. The concept is similar here with the pitch. So high pitch means you can correlate it with the high angle of attack. It's not exactly the same, but you can correlate here. So high pitch means you'll get higher speed. The air it will be pushing is more in high pitch propellers as compared to low pitch propellers. But because of high pitch, it will be very difficult to slow down the plane. In general, it is preferred when you're making heavy lift drones or steady flight if you want a steady flight. With high pitch comes more load on propeller. So it takes little longer to spin, which reduces the agility. So if you want your plane to be very agile, you'll want to use low pitch propellers. So they're little slower for forward speed at a given RPM. But also low pitch means that less air per revolution. So engine will have less load. So it can spin up faster and will also be more responsive. So if you want for racing purpose, you might want to use low pitch propellers. Again, you can go dive into it. Moving on, you can choose either two blade propellers, three blade propellers, or multi blade propellers. So the main difference between two blade and three blade propellers are the two blade propellers provide a little less thrust as compared to three blade propellers. But two blade propellers are much more responsive and much more agile. But three blade propellers are a little less responsive. And as you keep increasing the blades, the responsiveness gets little less, but it becomes more stable. So according to your mission, whatever your problem statement is, you will choose whatever blades you want in your propeller. When you go for multi-blade propeller, it also gets quiet. So if you want that in your problem statement, if it's there, you might want to consider multi-blade propellers. Also, when you see propellers online, the dimensions are represented as A, B, C, D. So it'll be some numbers like 50, 40, 30, 40. So what exactly do you mean by those numbers? So in case it is 50, 40, the 50 is the diameter and the 40 is pitch. So 5.0 inches is the diameter and 4.0 inches is the pitch. Now let's dive into the electronics here. So the first thing is ESC. So what is ESC? ESC is electronic speed control. As the name suggests, you are controlling the speed of the motor here. So how will you choose ESC for your drone? So ESCs have rating. So whatever your motor is rated for, your ESC rating should be higher than that. So you can see there, you can connect your motor, battery, and transmitter. It is also connected by a power distribution board, and we'll see about power distribution board ahead. So you have to make sure that your ESC rating is higher than your motor rating. Also, it is connected by something called BEC, that is battery eliminator circuit. It is an electronic voltage regulator. So basically, when you connect the battery, it will provide you a much more higher voltage than what is required to power your servos or your receiver, and you don't want to fry them. So you cannot directly give them the high voltage. So you have to step down the voltage. That is done by something called BEC. So some ESCs have BEC inbuilt them and some ESCs don't. So you have to check before getting the ESC, you have to check if they have BEC inside them or you have to get an external UBEC. For more on ESCs, you can dive into this link over here. Now comes power distribution board. So why do you even use power distribution board? So it is used to centralize and simplify the connections. So you can connect the ESCs, the batteries, and everything without a lot of wiring. And what you want in the drone is it to be very like you don't want a lot of wiring because it'll be messed up. So that is why power distribution board is used. Now, how will you choose the power distribution board? So whatever you're connecting to the power distribution board, the ESC is the motor. So whatever the maximum draw is, the combined maximum draw, you want you want your PDB to be able to handle more than whatever your maximum draw is. So that is how you will choose your power distribution board. Now, nowadays, if you see the drone frames, they have integrated power distribution board. So you might, when checking the drone frame, you might want to check if they have integrated power distribution board. And for more on power distribution board, you can go through this link. Now comes battery. So before diving into what battery do you want, here are some properties of battery. So the first one is energy density. So as the name suggests, energy density is how much energy your battery contains in the proportion of its weight. So you want more energy density. Then second comes mAh rating. mAh rating is basically how long it can power your device. So if it is 1000 mAh, it means it will provide 1 ampere current for 1 hour. If it's 5000, it means 5 ampere current for 1 hour. Now comes C rating. So C rating is basically measurement of current in which battery is charged or discharged at. So basically, if your battery is 1000 mAh and if it is rated as 1C, it means it can provide 1 ampere current for 1 hour. And when you increase the C rating, so let's say it is 2C, it means that it will provide 2 ampere current but for half an hour. So basically, as you keep increasing the C rating, the current you will increase, but the time will decrease. The third thing here is nominal voltage. So what exactly is nominal voltage? It is the almost the average voltage at which your battery operates in the discharge cycle. Now here are the two main types of battery that we usually use, LiPo battery and Li-ion battery. So the main differences here are that LiPo batteries have usually higher discharge rates, means you can get higher current bursts. But in Li-ion battery, it's not generally suitable for it. And LiPo battery is a little lighter as compared to Li-ion batteries. So LiPo batteries, the weight difference is not that much. It's just around 14 grams. So you might want to consider it or not. The third thing here is energy density, where Li-ion battery wins. So Li-ion battery has higher energy density, which means longer flight times. The fourth thing here is C rating. So LiPo batteries have higher C rating, whereas Li-ion batteries have lower C ratings. So all these things you can consider when comparing which battery you want to choose. Now, if you have chosen LiPo battery or Li-ion battery, now how will you choose what battery do you want? Like what is the rating of the battery you want to use? So for that, you will have to get the current draw and the expected flight time. So according to your problem statement, you'll get the expected flight time of your what drone you're making and the current draw. And when you multiply it, the rating of the battery should be higher than the multiplication of current draw and the expected flight time. Now, if you have chosen LiPo battery, when you're charging the LiPo battery, 4.2 volt is the maximum charge voltage and 3.2 volt is the minimum. So if the voltage is lower than 3.2, it will damage the battery. If it's more than 4.2, then there's a risk of fire. So you have to consider this. Also for both LiPo and Li-ion battery, 3.7 is the nominal voltage. Now, here is the difference between LiPo and Li-ion. You can ignore this NIMH and you can go over this. Moving on, the one thing here important is the number of cells in series. So if it is 1S, it means one cell. If it's 2S, two cells, 3S, and you can go on. So it depends on the voltage also. So if it's 1S, it's 3.7. The nominal voltage is 3.7. If you keep increasing, nominal voltage will also increase. So you have to, when you're connecting the components of your drone to the battery, you have to check if it's the same S rating. So if it's 3S, you have to connect it with the 3S. But if you're connecting, if there is a mismatch, so if your flight components are rated for 3S and you're connecting 6S or higher, or even 5S, if you connect it, then you'll fry your components. They'll overload and you'll fry your components, and you don't want that to happen. So you have to match the S rating. Also, when charging the battery, you have to match, otherwise you will either destroy your battery or the charger. For more on battery, you can go through this link. Now, very important thing here is how will you decide the weight of your drone? So the one important thing here is the thrust to weight ratio. That is generally considered around 2 or higher than 2. So thrust to weight ratio, you don't want it very high also, because with high thrust to weight ratio, you will get very high good performance, but also you'll have difficulty in controlling the drone, because if thrust to weight ratio is high, when you give even a small input, you'll get a very large output. So controlling it will be a little problem. Now, thrust, you can approximate the thrust provided by the propellers through this formula. So here's the RPM, the diameter, the pitch, and the velocity of the air. So you can estimate the thrust from this of the propellers from this formula. And here's the link for the derivation. So you can go through it also. Moving on to very important thing, that is motor. So we generally use BLDC motor, that is brushless DC motors. And a very important property of brushless, the one thing that you want to consider is the kV rating. So what exactly is kV rating? kV rating is the number of revolutions per minute, that is the RPM a motor gives when it is turned to 1 volt. So if you provide 1 voltage and there is no load attached to it, you're not attaching any propeller or anything, the RPM it gives, that is the kV rating. So here, how will you choose the motor? So basically the torque that motor provides, it depends on the volume. So if your motor has more volume, it means it has more torque. So how will you get that what is the volume? So it is estimated by the stator dimensions that is provided in general with the motors. So the stator dimensions is provided like ABCD, and AB will be the diameter and CD will be the height. So you can estimate the volume and you can compare other motors. So how does the kV rating depend? So basically, if you're using large propellers, they are typically paired with low kV rating motors. Whereas if you're using small propellers, they're usually paired with high kV rating motors. So if you're using 1000 kV rating motor, it is generally used for 10-inch propellers. And if you go higher in the kV rating, like around 1400 kV, it is used for 8-inch propellers. And for more on motors, you can go through this link. Now here are some recommended prop diameters and the motor size. So if you have decided what prop diameter you want, here are the recommended motor sizes. And also, if the prop diameter is decided, you can go through the battery voltages and the recommended motor kV ratings here. So you can choose accordingly. So this was all about the drone sizing from my side. Now Tisha will take you through the eCalc tool. Handing over to Tisha.
Is my screen visible?
Yes, yes.
So, hello guys. Myself, Tisha Agrawal, a 2B Sophie in the aerospace department and also a convener of the Aeromodelling Club. So, I'm here to discuss few points about the eCalc tool, which is a nice tool, a nice online tool that would help us in simulating and fine-tuning of the drone setups virtually. It would help us save time, money, and ensure better flight performance before we even power up our motors. So with the help of this tool, we can simulate and optimize our drone propulsion systems, including motors, ESCs, propellers, and batteries. It helps predict performance parameters like thrust, flight time, efficiency, and power consumption before actual testing. So let's get started with the basics. So the first thing which we are going to discuss is the rotor configuration. So in general for a drone, there are two types of rotor configurations possible. First is flat and second is axial one. The flat one is the most commonly found in probably the maximum drones, quadcopters and the hexacopters which would be found in the market, in which only one propeller is mounted on one particular rotor. Whereas in the axial rotor configurations, two propellers are mounted on a single rotor and they rotate in counter directions. The axial system is more efficient and stable. Also, it is quite resistant to rotor damage as well. But the axial system is relatively more expensive, a bit complex, whereas the flat rotor configuration is relatively less expensive and easier to operate. Also, as you could see that in the image which I have attached, there are three configurations which are possible for the given weight of the drone which we would be inputting, including drive, without battery, and without drive. So without battery is, I think, self-explanatory. Including drive would mean if we are including the weight of all three, motor, battery, and ESC, and without drive would mean if we are not including that weight of motor, battery, and ESC. Next comes out to be the FCU tilt limit. So the FCU tilt limit refers to the maximum tilt angle that the flight control unit allows for a drone or a multi-copter during flight. This helps us maintain stability and control, preventing excessive tilting that could lead to loss of controller crashes. So this is something which we would be manually inputting in our FCU, because we don't want our drone to roll more than a particular angle. क्योंकि अगर वैसा हो जाएगा, so it would be very difficult for us to control the drone. Also, it would be very unstable in that case. Therefore, हम एक maximum limit set कर देते हैं अपने drone के ऊपर, so that the drone won't cross that limit basically, and it would be under control for the most time of the flight. Next comes out to the battery. So for the battery, one of the most important parameter is the C rate, as discussed earlier in the drone sizing. that for an example, if there's a battery which is rated at 1000 milliampere hour and it is at 1C, then it would be providing 1 ampere for 1 hour. The same battery discharging at 0.5C should provide 500 milliamperes for 2 hours, and so on. As in the shown example, the lithium polymer battery is rated at 2500 milliamperes hour, and the C value is rated from a minimum value of 80 to a maximum value of 120. So as we've discussed that the obviously if the C rating would be more, the flight time would be less, and if the C rating would be less, the flight time would be more. And hence we can easily conclude that increasing or decreasing the C rating will result in a change in discharge time. Okay, so apart from that, there's a factor which is termed as maximum discharge rate. So maximum discharge rate is, I think, something very important which we should definitely have an eye upon, because maximum discharge rate refers to the maximum percentage of the total capacity to be used for a flight. Exceeding the maximum discharge can damage the battery, cause overheating, fire, or explosion. So what the thing is that na कि whenever we are flying our drones or whatever, हम नहीं चाहते कि हमारी battery totally dead हो जाए, because if the battery would be totally dead or it would go below a certain percentage, then in that case the lifespan of the battery would be shortened by quite a lot. Also, there might be chances of some hazards taking place. So, in order to prevent those hazards and in order to maintain the battery life, we must take care of the maximum discharge rate. That is like जैसे example में देख पाएंगे, the maximum discharge rate which we have entered is 85%. That means that we don't want our battery percentage to go below 15%. Whenever we flying our drone or using our drone for whatever purposes, we must make sure that the minimum percentage charge of the battery is 50 and it must not go below that. Next comes out to be the ESC. So obviously the ESC stands for the electronic speed controller, and the maximum current permissible of ESC must always be greater than or equal to the current rating of the motor, because obviously if the maximum current over the peak limit of the ESC, we should select a stronger ESC to avoid damage, because if the current rating of the motor would exceed the current permissible of ESC, then in that case the ESC would get damaged. To avoid that damage, we must ensure we must select a stronger ESC so that the ESC would not get damaged and the maximum current permissible of ESC would be greater than or equal to the current rating of the motor. Next comes out to be the motor. So one of the very important factors of the motor is the kV rating of a motor, in which the kV rating stands for the number of revolutions the motor would be spinning when no load is attached to the motor. And hence the torque would be inversely proportional to the kV rating given the same electric current. And also, as we have seen in the definition, that the kV rating doesn't account for load or efficiency because it's an ideal no load speed. We have not attached any load or any propeller to the motor, and we're simply spinning it for a minute. When we have applied 1 volt to it, the number of revolutions would it make would be the kV rating of the motor. Also, as the torque is inversely proportional to kV rating given the same electric current, it's a thing which we should always have an eye upon while selecting the proper motors, because for an example, if want to make drone for the racing purposes, then we would want our motors to spin at a higher rate, and we would not be concerned much about the torque which would be getting produced by the motors. And hence, if we are making drones for the applications such as racing drones purposes, then we must try to select drones with higher kV ratings, because a higher kV rating motor would result in a higher RPM, and yeah, it would produce less torque. But obviously for racing drones, we are concerned with higher RPM, hence we should try to select a motor with a higher kV rating. Next is a tool which is again provided by the eCalc tool itself, which is a prop KV wizard, which is a nice tool that helps match a motor's KV rating with the right propeller size and battery voltage to optimize thrust, efficiency, and flight time in drones for RC aircraft. So how would it help us? It would simply help us in preventing overloading the motor or ESC, and it would ensure balanced flight characteristics. Next comes out to be the propeller. So for a propeller, there are generally two constants which we should always need to study before selecting the right type of propeller. There are thrust constant and power constant. So first we would study about the thrust constant. So thrust constant in simple words indicates how efficiently a propeller is able to generate thrust at a given speed. It talks about the efficiency. So obviously for an ideal propeller, the thrust constant should be equal to 1. Because for most efficient propeller, the thrust constant would be equal to 1. That means it would be converting the absorbed power into thrust at the most optimum level. Next is power constant. So power constant, in simple words, it is a measure of the aerodynamic resistance that the propeller is facing. That is the drag it would generate during rotation, and this constant represents the aerodynamic drag, or how hard the air would be resisting the blades while cutting through it. So yeah, we are done with these basic parameters, which we should always like have to select before operating on this eCalc tool. So like directly, let's jump onto the example. And like as you would be seeing in this example, there are 6 parameters which the tool itself is giving us in the form of outputs. Those 6 parameters are load, hover flight time, electric power, estimated temperature, thrust to weight ratio, and specific thrust. So let's try to understand what all these 6 parameters are representing and how would they help us in making our drone perform even better. So first is load. What does the load represent? Obviously, so it is a parameter that specifies the discharge rate of a battery. Second is hover flight time. So as the name itself is suggesting, it represents the duration over which the drone would be able to fly at its optimum performance without affecting the performance and the nature of the drone. So the more the higher the hover flight time is, obviously the better it is. Second is electric power. So the electric power of current is the maximum value of current in relation to the specific motor limit, maximum 15 seconds. So what happens is the battery, there's a specified value of current beyond which if the current would be flown for more than 15 seconds in the battery might simply get fried out, or the battery might simply get exploded or might catch fire. So electric power is something which we should always have an eye upon because it is getting represented in watts or amperes, and it's a maximum value which is to be flown for a maximum 15 seconds. If it is getting flown for more than 15 seconds, then again it might damage our motor or battery. Next comes out to be the estimated temperature. So again, as the name is suggesting, the estimated temperature is the temperature which is getting produced in the battery. Obviously, it should be as low as possible because if the temperature produced would be more, then it might lead to overheating. It might even catch fire at worst cases, and obviously it would not perform at its optimum and base level. The fifth ratio is thrust to weight ratio. So what does the thrust to weight ratio represents? It is basically indication for the flight performance. The higher the thrust to weight ratio is, the more agile our copter would be, and indirectly it represents the throttle which is required for hovering. The ideal thrust to weight ratio should be more than 2, and obviously it should be obviously be greater than 1, because if the thrust to weight ratio is not greater than 1, then the drone itself would not leave the ground, and obviously then the purpose of the drone would not be served. So ideally, the thrust to weight ratio should be tried to be kept at nearly around 1.8 to 2. If it is more than 2, then it would be pretty good to have. The last parameter is specific thrust. So the specific thrust is something related to the overall efficiency of the propeller, because it represents the thrust which is getting produced per unit air mass flowing through the propeller. Along with these 6 parameters, the tool also gives us a beautiful graph as an outcome. In this graph, we can see there are 5 to 6 regions in which the data is getting displayed. First, as you can see, it is the orange shaded line. Orange shaded line is representing us the flight time if there would have been no drag in ideal case scenarios. But as we are living in real world where there would obviously be standard drag, so the flight time with standard drag is represented by the light blue line. Similarly, the orange line is representing the range if there would have not been any drag, and the dark blue line is representing range with the standard drag. Along with that, there is a green vertical zone in which the green vertical zone is representing the optimum airspeed, which comes out to be 35 to 40 kilometers per hour in this example we have taken. That would give us the maximum range considering the drag. And also there's one orange shaded vertical line on this graph which you would be able to see, and it represents the aircraft theoretical maximum speed, which comes out to be around 55 to 60 kilometers per hour in this example. So yeah, at last but not the least, we must always keep an eye upon the remarks, because sometimes if we are not able to figure out what the proper specs of the drones should be or would be, reading itself the remarks might just solve majority of our problems that we might be actually facing. For an example, the remark in this states that the maximum current is over the peak limit of the speed controller, and hence we should select a stronger ESC to avoid damage. So if you're quite confused, key, what should be done, like error kahan pe aa raha hai. So simply reading the remarks might just solve our problem. So yeah, we are done with the slides now. Like, let's hand on move to the eCalc tool itself to see how it should be done. So yeah, this is your eCalc tool, which you would be easily able to find once you are like typing the eCalc tool online. So in this, you can see in the general section, there's model weight. Say our drone weighs 850 grams. The volume it is occupying is 30 ounce, and this is all without a battery. See the number of rotors in our drone are 4. It is flat configuration. Frame size is something which, like, obviously you would be inputting whatever frame size of the drones you would be having. If any FC tilt limit you would be inputting to the drone, that is something which we can input over here. And the next three things, which are field elevation, air temperature, and pressure, they're obviously environment dependent. So wherever you would be flying your drone, these are some of the parameters जो आप वहाँ के उसमें input कर देंगे. Next, let's assume the battery which we are using is say 4500 milliamperes with the C value of 80 to 120. Okay. Next, let's assume the battery configuration is 3 series and 1 parallel. Maximum discharge rate is 85% and rest of the values are as shown. Let's assume that the maximum value of the controller is say 30 amperes. Along with that, the motor is say produced by AXI company. And the propellers which we would be using are gem fan with a diameter of 10 inches and the pitches of 4.7 inches. So right now the data which I have input is like totally random, like there is no reason why you would want to input these values. This is like total random values just for the purpose of demonstration, so as to see how the software would work. So yeah, as you would be seeing over here, what the remark is. So what the remark states is that the maximum power is over the limit of the motor. Please check the maximum power limits by the manufacturer limit, because the power maximum generated by the motor is 100 watts, but what the power is getting generated by the drone, it is 164.7 watts. So if we would be using एक्चुअल में these specs for our drone, तो अपना मोटर चल जाएगा. तो वो नहीं चले, उसके लिए हम क्या करेंगे, we must try to ensure कि जितना पावर हमारा ड्रोन प्रोड्यूस कर रहा है वो कम प्रोड्यूस करे. वो कैसे हो सकता है? So one very good thing to reduce the power produced by our drone is to simply reduce the dimensions of the propeller. That's a very nice thing to do. So let's assume that the propeller is 8 inches and the pitch has gone from 4.7 to 4.5 inches. So in this way, the power produced would be less. And yeah, now you would be able to see that yeah, there have been no remarks because अपना वो वाला issue solve हो चुका है, जिसमें जो power produce हो रहा था वो maximum motor के जो power produce उससे ज़्यादा हो रहा था. So इस केस में वो जल जाता, but because we have reduced the dimensions of the propeller, so that issue has been solved. So you can see कि अपने को इन 6 parameters में we have got a nice result, and इससे आप अच्छे से analyze कर सकते हैं. Like the load is 7.9, the hover flight time is 10.6 minutes, which is actually something pretty good. The estimated temperature is around 33 degrees centigrade, and these are all the values. Apart from that, again, this is the graph which we had discussed below, in which, like, again, the range has been represented, the flight time has been represented. You are given an optimum speed in order to, like, just आपको उड़ाना चाहिए to in order to attain the maximums, in order to attain the maximum ranges. We have been like getting a orange vertical line जो आपको maximum theoretical speed of the drone represent कर रही है. So yeah, this was all about the eCalc tool, and I feel that with the help of this simulation and the slides, you would have definitely gotten some idea so as how to use this tool and how could this be proving to be efficient while you would be constructing your own drone. So yeah, thank you. And I would like to call now Siddhesh for continuing the session on Pixhawk.
So hello everyone. I hope the screen is visible. Is the screen visible?
Yeah, it is.
Okay, so I'm Siddhesh Mane, convener of Aeromodelling Club and to be so in Department of CSE, and I'll be explaining about Pixhawk. So first question is what is Pixhawk? So Pixhawk is like a small controller, like computer that we use to control vehicles like drone, RC planes, boats, etc. So technically we call it as a flight controller. So flight controller basically it is like a brain of your drone. Like it controls the drone. It has multiple sensors like accelerometer, barometer, magnetometer, and we can also connect external sensors, which I usually tell more about these. So what Pixhawk does is that it uses the data from the sensors present on it and controls the drone basically. And one more thing, it is open source. That's why you can do lots of customization depending upon your need. So next is what can Pixhawk do? So first thing is it keeps the drone stable. Like your drone won't do any random movements like the makerspace drone it was doing. So next is it can make the drone fly complete autonomously. Like it can make your drone take off, then go to particular location and maybe survey that area, come back and land. All this autonomously. So how it does this? It does this like using the sensors which are present on Pixhawk, and we have to also there's a software which we run on it. And one more thing is that with Pixhawk, you can also control your drone manually, like with the transmitter. It also allows you to do that. So next is connections. So what you see here, this is a Pixhawk 6C. So it is of size of a AC remote, and it has lots of ports on it. So I'll be explaining about ports now. So this is first you see here it's a power one. This is a power port. It is used to power the Pixhawk. So the 5 volt supply from a battery is required. So as you have seen before, like you cannot connect your battery directly here because the battery voltage, the batteries you will be using maybe 3 years or 4 years, their voltage will be more than 12, 13, more than 15 volts. So that's why power module is used, which I will cover later in the slides. Then there's another power port. So it is just for backup. There is no need to use this. Oh, sorry. Now, next is SPS output. So this is used to control the cameras or servos. Like if your drone has a camera or gimbal or any servo, so you connect it here. Next is a telemetry port. So it is labeled as a telem1. So there are actually 3 telemetry ports. So there's a device called telemetry radio, which we connect here. I'll come on to that in the next slide. And also your flight computer, not flight controller, flight computer, they are also connected here, like Raspberry or Jettison Nano, they are also connected via telemetry port. Now, next is a PPM or SBus RC port. So here you connect the receiver of your transmitter, like if you want to fly the drone manually, so you connect the receiver here. Now, moving on to these 2 ports, FME PWM out and IO PWM out. So these are used for connecting, these are used for like connecting motors and servos to Pixhawk. Next here is a USB port. So it is used to connect USB devices to Pixhawk. Like it is not recommended to use this port to connect your laptop to Pixhawk. Like there is another port which is present on this right side of Pixhawk. There you can connect a USB cable to connect Pixhawk to your laptop. Now next is these 2 are the GPS port, GPS 1 and GPS 2. So any one can be used and depending upon the configuration of your GPS module. So moving next, this is power module PM02. So power module, like I told before, here you cannot connect the battery directly. So we use power module for that. So power module, basically it converts the battery voltage and gives a 5 volt supply. So what we do is we connect the power module to the battery from this side, and this one goes to power distribution board as Anamika explained. And there's one more pin which we connect into power port. So Pixhawk is powered. Now, next is telemetry radio. There are actually 2 of them. So one is connected to your drone, and it is connected to telemetry port, as I told before. And another one is connected to your laptop. So it acts like a link between your drone and the laptop. It sends signal. It sends data, like at what height your drone is and all that stuff. We'll come on to that later in the video. So next is PWM breakout port. So like as you saw here, there are 2 ports, FMU PWM out and IO PWM out. So we connect PWM breakout ports here. So these are like These are like small boards on which there are 8 pods. So you can connect up to 8 motors or 8 servos here. So that was about PWM breakout ports. So now moving on to next. This is a connection diagram of Pixhawk 6C. So as you see here, this is the Pixhawk 6C. I will briefly explain this. So this is the power one port. It is connected, like you see, there is a battery here, and there is power module, and it is all the way going up here and connecting to power one port. So it is powering the Pixhawk. Then this you see here, this is called GPS module. It is connected to GPS one on GPS two port. And then there's this telemetry radio, which I talked about earlier, and there's this all-in-one receiver. All those things, these are not actually necessary. So we will see more about LiDAR and all other sensors later in the slides. All right. So now moving on to sensors. Ayush will be explaining about the sensors. Yeah, Ayush.
Hello, am I audible, Siddesh?
Yeah.
So is my screen visible? Hello, is my screen visible to everyone?
It's not actually visible to me.
Wait a minute. Oh, so is it visible now?
Ayush, I will present my screen. You just narrate through it.
Yeah, okay. Well,
Okay.
hmm.
I hope it is visible.
Yeah. So moving on to sensors, there are mainly two types of sensor in a drone. या फिर एक फ्लाइट कंट्रोलर समझो आप. So there are set of internal sensors and दूसरे जो सेंसर होते हैं वो होते हैं external sensors, right? So इस स्लाइड पे आपको 4 सेंसर दिख रहे होंगे. Those are accelerometer, gyroscope, magnetometer and barometer. तो ये सब जो सेंसर्स है ना, these are internal sensors which are already present in your FC, जो भी आप पिक्सॉक यूज कर रहे हो ना उसके अंदर होते हैं. So what is an accelerometer? An accelerometer is a small sensor that measures linear acceleration in 3 axes, x, y and z axis. Accelerometer measures acceleration by detecting the displacement of a microstructure suspended on the springs. जो मतलब एक्सेलेरोमीटर होते हैं ना उसके अंदर छोटे से मतलब माइक्रो स्ट्रक्चर्स होते हैं, मतलब वो नैनो स्केल पे होते हैं एकदम, एंड दे हैव स्प्रिंग्स अटैच्ड टू इट. तो समझो आपकी मतलब अगर आपका ड्रोन आगे की तरफ हेड हो रहा है ड्यू टू इनर्शिया, दैट स्ट्रक्चर पीछे की तरफ जाएंगे, राइट, पीछे रहेंगे मतलब, तो उसकी वजह से क्या होगा, स्प्रिंग एक्सपांड होगी. सो जो एक्सेलेरोमीटर होता है दिस मतलब वो क्या करता है, ये जो मूवमेंट चेंजेस होता है इसको मतलब इससे रेजिस्टेंस चेंज होता है, सेंसर होता है ना उसके अंदर का रेजिस्टेंस चेंज होता है. सो एंड द आईसी कन्वर्ट दिस चेंज टू वोल्टेज. तो मतलब जो भी एफसी में आईसी होता है तो इसको वोल्टेज में कन्वर्ट करता है, जो वोल्टेज को डिजिटल वैल्यू में कन्वर्ट कर देता है बाद में. सो ऐसे मतलब जितना एक्सेलरेशन है वो मेजर हो जाता है. देन नेक्स्ट सेंसर जो है हमारा वो है गायरोस्कोप. गायरोस्कोप इज अ सेंसर दैट मेजर्स एंगुलर वेलोसिटी. मतलब एंगुलर वेलोसिटी जो होती है ना, रोल करते हो या फिर पिच करते हो या फिर यो एक्सिस, ये तीनों एक्सिस के अराउंड एंगुलर वेलोसिटी मेजर करने में मदद करता है. इट इज जस्ट सिमिलर टू एक्सेलेरोमीटर, थोड़ा सा मतलब इसका इंटरनल स्ट्रक्चर डिफरेंस होता है. Then magnetometer detects the head Earth's magnetic field to determine orientation. यानी मतलब अगर आपका ड्रोन आगे की तरफ जा रहा है पीछे की तरफ जा रहा है, सो मतलब मैग्नेटोमीटर क्या करता है, ये जो मूवमेंट्स हो रहे हैं ना मूवमेंट्स को डिटेक्ट करता है अर्थ की मैग्नेटिक फील्ड की मदद से. मतलब मैग्नेटिक फील्ड चेंज होती है, एक प्लेस से दूसरी प्लेस पे आपका मतलब कॉर्ड जा रहा है तो मैग्नेटिक फील्ड भी चेंज होगी वहां से, तो ये डिटेक्ट कर लेता है. देन जो हमारा फोर्थ सेंसर है वो है बैरोमीटर। बैरोमीटर क्या है? इट इज सेंसर विच मेजर्स एल्टीट्यूड। वो भी एल्टीट्यूड कैसे मेजर करता है? ड्यू टू हेल्प ऑफ एटमॉस्फेरिक प्रेशर। जैसे कि आपको पता होगा कि ऊपर जब जाते हो आप तो एटमॉस्फेरिक प्रेशर डिक्रीज होता है, एल्टीट्यूड जैसे जैसे बढ़ता है। तो ऐसे ये डिटेक्ट कर लेते हैं, नीचे आते हैं तो एटमॉस्फेरिक प्रेशर बढ़ता है, तो वो जो प्रेशर का जो चेंज है ना उसके हिसाब से एल्टीट्यूड मेजर करता है। तो मतलब बैरोमीटर जो है इट इज नॉट वेरी मच एक्यूरेट। इसके कंपनसेट करने के लिए वी यूज डिफरेंट टाइप्स ऑफ सेंसर, जैसे कि लाइडार हो गया एंड ऑप्टिकल फ्लो सेंसर हो गया। इसके बारे में मैं आपको आगे बताऊंगा। ऑल्सो मतलब एक्सेलरोमीटर, गायरोस्कोप एंड मैग्नेटोमीटर पिक्सॉक आर पार्ट ऑफ आईएमयू। आईएमयू का फुल फॉर्म होता है इनर्शियल मेजरमेंट यूनिट। सो हम नेक्स्ट स्लाइड पे जाते हैं अभी। हाँ, सो हमारा फर्स्ट सेंसर जो जो एक्सटर्नल सेंसर है वो है जीपीएस। जीपीएस का फुल फॉर्म क्या है? इट इज ग्लोबल ग्लोबल पोजिशनिंग सिस्टम। इट इज अ सैटेलाइट बेस्ड रेडियो नेविगेशन सिस्टम ओन्ड बाय द यूनाइटेड स्टेट्स। मतलब यूनाइटेड स्टेट्स ने वर्ल्ड वार के टाइम पे डेवलप किया था इसे। मतलब दिस वाज अ मिलिट्री टेक बिफोर, जो अभी मतलब सिविलियन यूज के लिए अवेलेबल, गूगल मैप्स वगैरह यूज करते होगे आप। सो जीपीएस है। इंडिया ने अपना खुद का सिस्टम भी डेवलप किया, आपको पता होगा। बट स्टिल वी आर इन डेवलपिंग स्टेजेस। इनका जो है मतलब इट इज बीइंग यूज्ड फॉर मतलब वेरी लॉन्ग टाइम। It is one of the global satellite system that provide geolocation and time information to anyone who has a GPS receiver. तो आगे मैं आपको जीपीएस रिसीवर के बारे में बताऊंगा। देयर आर जीपीएस मॉड्यूल, उसकी मदद से वो सैटेलाइट से कांटेक्ट करता है। सो वी गेट मतलब प्रिसाइज पोजीशन एंड लोकेशन टाइम हमारा। सो मूविंग ऑन टू नेक्स्ट सेंसर। हाँ, तो वर्किंग ऑफ जीपीएस। तो जीपीएस कैसे काम करता है? यू विल बी क्यूरियस कि जीपीएस कैसे काम करता है। सो जीपीएस बेसिकली वर्क्स ऑन ट्राइलेटरल सिस्टम। It uses 24 satellites all over the world to determine positions. But to determine a particular position, we would require only 4 satellites. मतलब अगर आपको आपका क्वाड कहीं मतलब आप उड़ा रहे हो, लॉन्ग रेंज मिशन कर रहे हो आप, तो उसमें जीपीएस सेंसर होता है। तो वो सेंसर क्या करेगा? रिसीवर 4 सैटेलाइट से कम्युनिकेट करेगा। मिनिमम 4 सैटेलाइट्स रिक्वायर्ड, वरना उसके बिना आपका ड्रोन आर्म नहीं होगा, ड्रोन जीपीएस काम नहीं करेगा। Each satellite constantly sends a radio signal with the satellite's exact position and time the signal was sent. तो मतलब क्या करेगा? 4 सैटेलाइट है तो चारों से जिन चारों से कनेक्टेड होगा तो उससे ये क्या करेगा कि सिग्नल भेजेगा। सी इफ ड्रोन इज एट पोजीशन ए एंड इट मूव्स टू पोजीशन बी, तो चारों सैटेलाइट्स के बीच का डिस्टेंस अलग होता है। तो मतलब ये ड्रोन क्या करेगा, सैटेलाइट्स क्या करेंगे कि मतलब ये सैटेलाइट्स पे सिग्नल आके वापस जाने में कितना टाइम लगा है, दूसरे सैटेलाइट से टाइम कितना लगा है, तीसरे सैटेलाइट से कितना लगा है, चौथा सैटेलाइट से कितने लगा है। तो क्योंकि इसका रेडियो सिग्नल्स होती है दे ट्रेवल्स एट स्पीड ऑफ लाइट, राइट। तो मतलब उसके हिसाब से वो चारों का मिलके ये कैलकुलेट कर लेते हैं कि मतलब पोजीशन क्या है, इसका एल्टीट्यूड क्या है, लॉन्गिट्यूड क्या है। मतलब इसका सिंपल है, इसका वर्किंग जो है उतना मुश्किल नहीं है। इट इज सिंपल एंड ऑल्सो मतलब मैं आपको फीचर्स बताऊंगा जो जीपीएस के होते हैं। जीपीएस कहाँ कहाँ पे यूज होता है? अगर आपको ऑटोनोमस फ्लाइट करनी है तो उसमें जीपीएस यूज कर सकते हो, या फिर इफ यू आर मतलब न्यू पायलट एंड आपका ड्रोन कहीं दूर गया है, यू कैन प्रोग्राम अ फीचर कॉल्ड एज आरटीएच। इसका फुल फॉर्म होता है रिटर्न टू होम फंक्शन। उससे क्या होता है कि मतलब एक क्लिक पे आपका ड्रोन जहां से लॉन्च किया था ना वहां पे वापस आता है। ये कैसे आता है वापस? बिकॉज ड्यू टू हेल्प ऑफ जीपीएस। जीपीएस को पता है इसका लॉन्च करने का लॉन्जिट्यूड क्या था, लैटिट्यूड क्या था एंड उसका मतलब पोजीशन क्या था। तो वहां पे वापस आ जाएगा ऑटोमेटिकली। एंड तीसरा है सर्वे के लिए, मिशन प्लानिंग आप जब करोगे तो उसमें भी काम आ जाता है। एंड आल्सो डिलीवरी सर्विसेज, जैसे आजकल अमेजोन भी एक्सपेरिमेंटेशन कर रहा है जीपीएस की वजह से, मतलब उसको एड्रेस पर पता चल जाता है ना जैसे गूगल मैप्स होता है, तो वैसे डिलीवरी सर्विसेज में काम आता है। एंड लास्ट वाला है कि मॉनिटर करने। तो मॉनिटर द थिंग्स, मतलब ऊपर से आप पेट्रोलिंग कर रहे हो, कुछ भी कर रहे हो पुलिस, तो उसके लिए काम आ जाता है। सो सिद्धेश कैन यू चेंज दिस स्लाइड? हाँ, तो हियर यू कैन सी डिफरेंट टाइप ऑफ जीपीएस मॉड्यूल। यहाँ पे एक नीचे जीपीआरसी का दिख रहा होगा एंड ऊपर एक जेनेरिक GPS module, yeah. So a GPS module is a small device that receives signal from satellites and tells your Pixhawk where the drone is. It typically contains जीपीएस चिप। मतलब इसका जो कंपोनेंट होता है ना उसमें एक जीपीएस चिप होती है। इट इज एन आईसी मतलब इंटीग्रेटेड सर्किट विच कैलकुलेट्स पोजीशन ऑफ ड्रोन ऑन अर्थ। वी विल यूज M8 and M10 जीपीएस विच आर लेटेस्ट जीपीएस राइट नाउ। पहले M4 भी आते थे, M5 भी आते थे। नाउ करेंटली वी आर यूजिंग M8 and M10। देन सेकंड पार्ट होता है उसका सिरेमिक एंटीना। एंटीना जो होता है ऑब्वियसली एंटीना से क्या मतलब होता है रेंज एक्सटेंड होती है। एंड सिरेमिक एंटीनास आर वन ऑफ द बेस्ट एंटीना, उससे मतलब बहुत एक्सटेंडेड रेंज मिलती है हमें। तीसरा जो कंपाउंड होता है उसमें देयर इज अ कंपास टू नो डायरेक्शन। सी जीपीएस से आपको पता चलेगा कि पोजीशन क्या है, बट उसका डायरेक्शन करंटली ड्रोन का या फिर आपका जो भी व्हीकल में यूज कर रहे हो उसका डायरेक्शन के लिए उसमें कंपास होता है एक। देन फोर्थ इज इंडिकेटर एलईडी, पावर ऑन के लिए या फिर कनेक्ट हुआ, ब्लिंकिंग पैटर्न्स होते हैं उसमें डिफरेंट डिफरेंट। तो ऐसे कंपोनेंट्स है। GPS is usually mounted on GPS stand in order to avoid electromagnetic disturbances caused due to motors and other electronics। हाँ, तो जो GPS होते हैं ना, उसे जनरली मतलब बाकी इलेक्ट्रॉनिक्स के पास नहीं रखते, मोटर्स के पास में या फिर FC या फिर ESC के पास में, क्योंकि मतलब इलेक्ट्रोमैग्नेटिक करंट इंड्यूस होता है मतलब मोटर्स के पास में या फिर ये, तो उससे GPS सिग्नल इंटरफेयर होगा। तो उसके लिए यहाँ पे आपको दिख रहा होगा दे यूज स्टैंडिंग्स, मतलब थोड़ा यहाँ पे समझो आपका ड्रोन का मेन बॉडी है तो उसके ऊपर एक ऐसा रॉड लगाया जाएगा एंड ऊपर GPS लगाया जाएगा। तो ऐसा इलेक्ट्रोमैग्नेटिक इंटरफेरेंसेस अवॉइड होते हैं। एंड एक और बात, GPS ओनली वर्क्स व्हेन यू आर इन ओपन एरिया। इफ यू आर इन एनी बिल्डिंग या फिर ये, तब GPS काम नहीं करेगा। ये मतलब बहुत इंपॉर्टेंट चीज है। तो इसका काउंटर करने के लिए वी हैव डिफरेंट टाइप्स ऑफ सेंसर जो मैं आपको आगे बताऊंगा। सो मूविंग ऑन टू नेक्स्ट स्लाइड। हाँ, सो हमारा अगला सेंसर है लाइडर। लाइडर स्टैंड्स फॉर लाइट डिटेक्शन एंड रेंजिंग। It provides accurate distance measurements crucial for terrain following, obstacle avoidance and precision landing। तो लाइडर क्या करता है, इट सेंड्स अ बीम ऑफ लेजर और लाइट एंड वो मतलब उसके वापस बाद में बाउंस होकर वापस आ जाएगा। उसके बाद से क्या करता है, इट क्रिएट्स अ 3D एनवायरनमेंट। देयर इज आल्सो 2D टाइप्स ऑफ लाइडर, बट मोस्टली जब आप ड्रोन वगैरह यूज करोगे ना, यू यूज 3D लाइडर्स। तो लाइडर से क्या होता है, इसका मतलब 3D एनवायरनमेंट क्रिएट कर लेता है। मतलब जहाँ जहाँ पे ऑब्स्टेकल क्रिएटेड वहाँ पे बम्प्स बन जाते हैं, मतलब जो फ्लाइट कंप्यूटर से कनेक्टेड होता है। तो फ्लाइट कंप्यूटर क्या होता है, लाइडर से डेटा लेके एक 3D एनवायरनमेंट बना देता है। सो मतलब इससे क्या होता है कि इट नोज अबाउट इट्स सराउंडिंग। जो कॉर्ड उड़ रहा है अगर उसके सामने पेड़ आ गया, लाइडर कैन डिटेक्ट द ट्री एंड ड्रोन नोज की ट्री इज डिटेक्टेड। तो उससे मतलब ड्रोन अवॉइड कर सकता है। सो हाउ डू यू कनेक्ट लाइडर टू योर FC या फिर फ्लाइट कंप्यूटर? इसका जो सपोर्टेड इंटरफेरेंस होता है वो है कि ऐसा मतलब I2C वाले जो पोर्ट होते हैं वहां से कनेक्ट कर सकते हो, या फिर यू कैन यूज UART पोर्ट और PWM पोर्ट। डिफरेंट कंपनीज ऑफ लाइडर यूज डिफरेंट इंटरफेसेस, तो मतलब वो आपके डिपेंड करेगा। सो जो कॉमन लाइडर सेंसर्स यूज होते हैं, वन ऑफ देम इज लाइटवेयर का SF11C। ये वाला जो आप देख रहे होगे ऊपर इसकी इमेज दिया हुआ है। एंड सेकेंड मोस्ट कॉमनली यूज इज बेनवेक TF मिनी, ये जो नीचे का है, बट दिस इज मोर एक्सपेंसिव मॉडल। सो ये थोड़ा लेस यूज होता है। इसका यूज केसेस क्या है राइडर का, इट इज हेल्पफुल इन लो एल्टीट्यूड फ्लाइट स्टेबिलिटी। मतलब आप नीचे उड़ रहे हैं तो फ्लाइट की स्टेबिलिटी के लिए काम में आता है क्योंकि ऑब्स्टेकल वगैरह डिटेक्ट कर लेता है। एंड आल्सो मैपिंग एंड स्लैम्स। स्लैम का फुल फॉर्म क्या होता है, साइमल्टेनियस लोकलाइजेशन एंड मैपिंग। इससे क्या होता है कि मतलब किसी जगह की आपको टोपोग्राफी निकालनी है, मतलब उसका टेरेन वगैरह मैप करना है, तो लाइडर की मदद से आप वो भी मैप कर सकते हो क्योंकि 3D एनवायरनमेंट क्रिएट करता है। तो 3D टोपोग्राफिक मैप बना लेगा है। एंड लास्ट इज ऑब्जेक्ट डिटेक्शन, जैसे मैंने आपको बताया ही था। ऑल्सो एक टिप देता हूँ, इंश्योर करेक्ट ड्राइवर एंड मैवलिंग कॉन्फ़िगरेशन फॉर प्रॉपर लाइडर ऑपरेशन। लाइडर, हर लाइडर का मतलब अलग ड्राइवर होते हैं, तो यू हैव टू इंस्टॉल ड्राइवर्स इन योर फ्लाइट कंप्यूटर। तो करेक्ट ड्राइवर इंस्टॉल करना जरूरी है वरना योर लाइडर काम नहीं करेगा। एंड ऑल्सो यू हैव टू यूज प्रॉपर मैवलिंग कॉन्फ़िगरेशन। मैवलिंग के बारे में आपको सिद्धेश आगे बताएगा। सो मूविंग ऑन टू अवर नेक्स्ट सेंसर। हमारा नेक्स्ट सेंसर है ऑप्टिकल फ्लो सेंसर। सो सी, ऑप्टिकल फ्लो सेंसर क्या करता है, इट मेजर्स मोशन रिलेटिव टू द ग्राउंड टू एड पोजीशन होल्ड स्टेबलाइजेशन स्पेशली इन GPS डिनाइड एनवायरनमेंट्स। सो ये क्या करता है, मतलब आप पोजीशन रिलेटिव करता है, ग्राउंड से जो रिलेटिव पोजीशन है उसे मेजर करता है ये जो लाइडर होता है। सो मैंने जैसे आपको कहा था कि GPS काम नहीं करता इंडोर्स में, तो इंडोर में आप करोगे क्या, इफ यू हैव बिग बिल्डिंग, मतलब अंदर आपका मिनी ड्रोन से आपको मतलब उससे या फिर कहीं पे मतलब केमिकल लीक हुआ या फिर कहीं एक्सीडेंट मतलब या फिर कोई इवेंट हुआ कैटास्ट्रॉफिक इवेंट, तो उसके अंदर आप काम कैसे, ड्रोन को अगर ऑटोनोमस बनाना है तो व्हाट यू कैन डू इज यूज ऑप्टिकल फ्लो सेंसर। ये क्या करता है कि मतलब ग्राउंड से उसका रिलेटिव पोजीशन डिटेक्ट कर लेता है लाइट, बीम ऑफ लाइट की मदद से। तो ये भी मतलब एक यू कैन यूज इट एज अ बेसिक GPS, मतलब ऑब्स्टेकल अवॉइडेंस के लिए वगैरह इंडोर में बहुत काम में आ जाएगा। ऑल्सो मतलब इसके जो कॉमन सेंसर है वन ऑफ देम इज PX4 फ्लो सेंसर, जिसका इमेज आपको स्लाइड में दिख रहा होगा। इट इज वन ऑफ द मोस्ट कॉमनली यूज सेंसर्स। एंड दूसरा है PMW3901। एंड देयर आर मल्टीपल टाइप्स ऑफ सेंसर। ऑल्सो सर इसका जो कनेक्शन होता है ना, यू डू इट वाया I2C पोर्ट और UART। एंड ऑल्सो एक इंपॉर्टेंट चीज, इसे कैलिब्रेशन की जरूरत होती है ओरिएंटेशन के लिए। इफ यू डू नॉट कैलिब्रेट इट, इट कैन गिव फॉल्स सिग्नल्स। एंड इसका जो यूज केस है, देर इज फर्स्ट यूज केस जैसे हमने आपको बताया था, इंडोर फ्लाइट विदाउट जीपीएस. सेकेंड यूज केस इज के प्रिसाइज होवर इन कन्फाइंड एरियाज. इफ यू वांट टू होवर ड्रोन, मतलब एक एल्टीट्यूड पे फिक्स एल्टीट्यूड पे होवर कर रहा है, यू कैन डू इट बाय बैरोमीटर. बट बैरोमीटर पे आप रिलाई नहीं कर सकते ज्यादातर. क्यों नहीं रिलाई कर सकते? बिकॉज वो किस पे वर्क करते, उसका प्रिंसिपल क्या है? एटमॉस्फेरिक प्रेशर, एंड इट कैन चेंज. जैसे ह्यूमिडिटी बढ़ गई तो प्रेशर बढ़ जाएगा, कम हो जाएगा. सो मतलब प्रेशर वेरी करते रहते हैं हर जगह पे, उसके मतलब एयर पे भी डिपेंड करेगा. सो यू कैन यूज ऑप्टिकल फ्लो सेंसर, ताकि उसकी वजह से प्रिसाइज एल्टीट्यूड पे होवर करेगा. एंड पोजीशन होल्ड ड्यूरिंग टेक ऑफ एंड लैंडिंग, ये भी एक पर्पज है. एंड एक इम्पोर्टेंट टिप, कंबाइन इट विथ रेंज फाइंडर. रेंज फाइंडर जो सेंसर्स होते हैं, जैसे लाइडर हो गया, उसके साथ अगर यूज करोगे तो एल्टीट्यूड का मतलब उससे एकदम प्रिसाइज आइडिया आ जाएगा. क्योंकि लाइडर की हेल्प से 3D मैप हो जाएगा, एंड इसकी हेल्प से भी मतलब लाइट के डिस्टेंस मेजर करके वो मतलब लाइट छोड़ के बीम वापस टाइम, कितना टाइम उससे एल्टीट्यूड मेजर करना, मतलब दोनों का जब यूज करोगे ना आप, तो इट विल गिव मोर प्रिसाइज मतलब एल्टीट्यूड का जो डेटा है वो. सो अगले सेंसर पे जाते हैं हम लोग. इट इज थर्मल सेंसर. हाँ. सो थर्मल सेंसर डिटेक्ट हीट सिग्नेचर्स, यूजफुल फॉर सर्च एंड रेस्क्यू, वाइल्ड लाइफ मॉनिटरिंग एंड इंडस्ट्रियल इंस्पेक्शन. सो मतलब इसके जो कॉमन मॉड्यूल्स है, वन ऑफ द कॉमन मॉड्यूल इज फ्लेयर कंपनी का लेप्टॉन मॉड्यूल. फ्लेयर कंपनी है, इसका मतलब इसका पेटेंट है इनके पास. सो मोस्ट ऑफ दी जो सेंसर मिलेंगे आपको ऑफिशियली, वो फ्लेयर कंपनी के ही मिलेंगे. इसके जो कनेक्शन होता है, यू हैव टू कनेक्ट इट बाय यूएसबी और सीरियल इंटरफेस. मतलब यूआरट यूज कर सकते हो या फिर यूएसबी यूज करना पड़ेगा. और वीडियो एंड डाटा स्ट्रीमिंग थ्रू मैवलिंक. मैवलिंक क्या होता है उसके बारे में आपको आगे सीधे बताएगा. मैवलिंक के वहां भी इसको कनेक्ट कर सकते हो. इसके यूज केसेस क्या है? नाइट टाइम विजिबिलिटी से बढ़ जाती है, तो नाइट टाइम फ्लाइंग कर सकते हो आप. रात को कोई सर्च एंड रेस्क्यू मिशन में आप यूज कर सकते हो, या फिर हॉटस्पॉट डिटेक्शन इन फायर फाइटिंग. या आपको पता होगा कि मतलब जब आग लगती है तो उसका एक हॉटस्पॉट होता है. फायर स्प्रेड अक्रॉस एरिया, बट उसका एक ही हॉटस्पॉट होता है. तो इसकी वजह से हॉटस्पॉट डिटेक्ट करके फायर फाइटर्स को हम बता सकते हैं कि कहाँ पे हॉटस्पॉट है, तो वहां पे वो लोग मतलब प्रिसाइज पानी मारेंगे. या फिर अनदर यूज केस थर्मल मैपिंग इन एग्रीकल्चर, वहां पे भी कर सकते हो. एंड ऑल्सो सर्च एंड रेस्क्यू मिशन में, जैसे कि मतलब ऊपर बहुत सारा मलबा पड़ा हुआ है बिल्डिंग का, एंड अंदर कोई इंसान फंसा हुआ है. सो उसके मतलब ह्यूमन बॉडी का एक स्पेसिफिक हीट सिग्नेचर होता है. तो हीट सिग्नेचर डिटेक्ट करेगा ड्रोन की, यहाँ पे ह्यूमन है, तो रेस्क्यूअर्स को इजी होगा वहां से रेस्क्यू करने के लिए. तो इट इज वन ऑफ द वेरी इंपॉर्टेंट सेंसर्स. ऑल्सो इसका एक नोट बताऊंगा आपको, रिक्वायर इमेज प्रोसेसिंग सॉफ्टवेयर लाइक क्यू ग्राउंड कंट्रोल प्लस कंपेनियन कंप्यूटर. आप इसे सिर्फ पिक्सॉक के साथ यूज नहीं कर सकते, आपको एक कंपेनियन कंप्यूटर चाहिए, फ्लाइट कंप्यूटर चाहिए होगा, उसको इससे मतलब कनेक्ट करना पड़ेगा. और फुल थर्मल एनालिसिस, इसका एक अलग सॉफ्टवेयर आता है, उसके थ्रू इसे रन करना पड़ेगा. सो इसका हो गया. आप अगले सेंसर्स के बारे में आते हैं. सम अदर सेंसर्स. यहाँ पे एक टेकीमीटर इन ड्रोन्स. जो ड्रोन्स पे टेकीमीटर यूज करता है, इट इज यूज टू मेजर रोटेशनल स्पीड, आरपीएम ऑफ मोटर्स और प्रोपेलर्स, which is crucial for monitoring motor performance, detecting faults, and improving control algorithms. And next, a pitot tube. A pitot tube is an airspeed sensor that measures the dynamic pressure of airflow to determine true airspeed of a drone. It you, it is commonly used in fixed wing and VTOL drones. जो VTOL वाले drones होते हैं, fixed wing planes होते हैं, उसमें होता है. to determine to मतलब for accurate navigation, stall protection and efficient flight control. नेक्स्ट जो सेंसर है वो है INS, inertial navigation system. It is a system that uses motion sensors to calculate a drone's position, velocity, and orientation by measuring acceleration and rotation over time. मतलब ये एक्सेलेरोमीटर एंड गायरोस्कोप का एक हाइब्रिड होता है, INS जो होता है. सो मूविंग ऑन टू नेक्स्ट स्लाइड. हाँ. हाउ डज द सेंसर टॉक टू द फ्लाइट कंट्रोलर और द फ्लाइट कंप्यूटर? आप सोच रहे हो कि मतलब सेंसर काम मतलब बात कैसे करते हैं, जो फ्लाइट कंट्रोल होता है उससे कम्युनिकेट कैसे करते हैं. सो मूविंग ऑन टू नेक्स्ट स्लाइड. मैंने आपको कहा था कि यू हैव टू कनेक्ट मोस्ट, जैसे ऑप्टिकल फ्लो सेंसर हो गया, अपना लाइडर हो गया, यू कनेक्टेड बाय यूआरट और फिर आई स्क्वायर सी पोर्ट. सो हम यूआरट से स्टार्ट करते हैं. यूआरट और सी यूनिवर्सल असिंक्रोनस रिसीवर ट्रांसमीटर is a hardware serial interface that allows external devices to be connected to the flight controller. कोई आपके पास एक फ्लाइट कंट्रोलर है, देयर आर मल्टीपल पैड्स, उसके ऊपर TXRS लिखा होगा. सो मतलब इससे क्या होता है, आप डायरेक्टली मतलब इससे मतलब इट इज मतलब सीरियल इंटरफेस होता है. मतलब जो मतलब एक्सटर्नल जो डिवाइसेस होते हैं ना, उसे मतलब जो आईसी होता है या फिर जो मेन उसका चिप होता है, जैसे मोस्ट ऑफ द फ्लाइट कंट्रोलर्स में STM32 यूज होता है, उसके साथ कम्युनिकेट करने में हेल्प करता है ये. सो इट यूजेस टू मेन लाइन्स, TX लाइन जो ट्रांसमीटर होता है एंड RX लाइन जो होता है रिसीवर. सो जो यूआर्ट होता है, मैं आपको एक इंपॉर्टेंट नोट बताऊंगा. सी इफ यू हैव मतलब आपके पास जीपीएस है एंड जीपीएस हैज TX पोर्ट, तो जो TX का पोर्ट रहेगा यू हैव टू कनेक्ट इट टू RX ऑफ फ्लाइट कंट्रोलर. या फिर अगर आपके पास कोई रिसीवर है उसका RX पोर्ट है, यू हैव टू कनेक्ट दैट RX पोर्ट टू द TX पोर्ट ऑफ फ्लाइट कंट्रोलर. तो RX से TX को जोड़ता है, TX RX को जोड़ता है, ऐसा होता है बस. also जो यूआर्ट के डिवाइसेस है जैसे जीपीएस मॉड्यूल हो गया, टेलीमेट्री रेडियोस हो गया, रिसीवर्स हो गया, रेस्पाई हो गया, ऐसे मल्टीपल मॉड्यूल यूज कर सकते हो. सो मूविंग ऑन टू नेक्स्ट स्लाइड विच इज आई स्क्वायर सी. हाँ, आई स्क्वायर सी इज अ सिंक्रोनस सीरियल कम्युनिकेशन प्रोटोकॉल. जो हमारा यूआर्ट था वो असिंक्रोनस प्रोटोकॉल था, ये कौन सा है, सिंक्रोनस प्रोटोकॉल है. इसका मतलब क्या है कि मतलब जो पहले मैं आपको बताता हूँ कि इट यूजेस टू वायर्स, जैसे यूआर्ट करता था RX एंड TX, ये क्या यूज करता है, SDL एंड SCL. इट इज मास्टर स्लेव आर्किटेक्चर. तो इसमें होता क्या है, यू कैन कनेक्ट मल्टीपल स्लेव डिवाइसेस टू मास्टर डिवाइस. मतलब आप मल्टीपल डिवाइस कनेक्ट कर सकते हो, जैसे एक्सेलेरोमीटर हो गया, बैरोमीटर हो गया, उसे एक ही I2C के पोर्ट को कनेक्ट कर सकते हो आप. तो मतलब ये इसका बेनिफिट होता है. बट इस डिसएडवांटेज इसकी, ये स्लो होता है. जो यूआर्ट होता है ना, वो मतलब ऑलमोस्ट 10 टाइम्स फास्ट होता है I2C के. दैट्स व्हाई यूआर्ट इज यूजुअली मतलब जीपीएस हो, क्योंकि उसमें ज्यादा डेटा आता है ना, सो इट नीड्स टू बी फास्ट. मैग्नेटोमीटर बैरोमीटर के कम डेटा आते हैं तो थोड़ा स्लो होने से कुछ फर्क नहीं पड़ता इसे. एंड टिपिकल I2C डिवाइसेस में आता है कि मैग्नेटोमीटर है, बैरोमीटर है, IMUs है, या फिर डिजिटल कंपास है, वो सब मतलब I2C से कनेक्टेड होते हैं. सो मूविंग ऑन टू नेक्स्ट स्लाइड. अदर कम्युनिकेशन इंटरफेस जैसे यूआर्ट हो गया, I2C हो गया, अलग अलग है. यहाँ पे बहुत सारे दिए हुए हैं, जैसे वन ऑफ देम इज CAN, कंट्रोलर एरिया नेटवर्क. अनदर इज SPA, सीरियल पेरिफेरल इंटरफेस. या फिर तीसरा है PWM, पल्स विड्थ मॉड्यूलेशन. इसके बारे में आपको पता होगा अगर आपने आर्डिनो वगैरह यूज किया है तो. एंड फोर्थ इज ADC, एनालॉग टू डिजिटल कन्वर्टर. मतलब एनालॉग जो सिग्नल्स आते हैं उसे डिजिटल में कन्वर्ट करता है. एंड लास्ट वन इज USB एंड SD कार्ड, जो कि ये तो मोस्ट कॉमनली यूज है. आप USB तो यूज करते होगे, मतलब कम्युनिकेशन प्रोटोकॉल ये भी, एंड SD कार्ड्स. सो हम नेक्स्ट स्लाइड पे आते हैं अभी. हाँ, तो इंट्रोडक्शन टू ऑटोनोमस ड्रोन. सो आई वुड लाइक सिद्धेश टू टेक ओवर दिस.
Hello. Yeah. Is the screen visible?
Yes.
Okay, so autonomous drones. Now we already saw that with Pixhawk you can make autonomous drones and that stuff, right? So autonomous drones, these are the drones that fly on their own. Like you don't need a transmitter to control them manually. So like if you like, we'll consider one example. Like there is a drone called a flood rescue drone. So what this drone does is that you have to just launch it, then it will take off, it will attain a particular altitude, and then it will go to the specified location. And say there's a village which is flooded. So it will scan that area, then search for victims, go to them, and drop the payload and come back again and land. So it's a very complex drone, you see, right? So now I will tell you the basics of making an autonomous drone. So we saw that with Pixhawk you can make autonomous drone, but with Pixhawk, what you can do is that you can tell the drone to take off and go to a particular location. But what about finding victims and going to them and releasing a payload and all that stuff? So for that, we use flight computer. Okay, so Pixhawk you saw, it was flight controller. And now we are going to discuss about flight computer. So in autonomous drone, along with the flight controller, you have to use a flight computer, right? So it works with a flight controller and it is mainly used for complex task calculations like say CVA processing and all those things. For example, I told you about the flood rescue drone. So like it would have multiple cameras and sensors. So with the help of cameras, it will be taking some videos of the surrounding, and then with those like footage it has captured, it will process them. So Pixhawk cannot do this processing work, right? So for that you have to use flight computer. So flight computer, these two are the commonly used flight computer. First is a Raspberry Pi, many of you might be familiar with it, and second is NVIDIA Jetson Nano. So Raspberry is cheaper than NVIDIA, but it's less powerful. And NVIDIA, whereas it is like a very powerful one, but it's also very expensive. And like most of the tasks which you will be making with the you require, they can be carried out with the help of a Raspberry. So you don't really need Jetson Nano. Okay, so in order to understand about flight controller and flight computer, I will tell you one example. Like consider there's a guy who's driving a taxi. He's a driver, but he can't see. He's blind. And there's another passenger who is sitting next to him, and he's looking everywhere and telling this guy where to go, where to turn, when to turn, and all those stuff. So the guy who's driving, it is like we can imagine him as a flight controller, and the one who is scanning the area, who is giving him instructions, he is flight computer. Okay, so I hope the difference is clear. So now we saw that there's a flight controller and there's a flight computer. So these two have to communicate with each other. Now, like flight computer, it has taken the footages of all the, what do we say? Say it has taken footages of a particular area, it has scanned, but it has to tell the flight controller, right? Because flight controller is driving the drone. So they communicate with each other with the help of a Mavlink. So Ayush has already talked about Mavlink. So what is Mavlink? Mavlink stands for Micro Air Vehicle Link. So it is a messaging protocol. So it is like Mavlink is used for communication between a flight controller and a flight computer. And also the LiDAR sensors and the onboard cameras, they also use Mavlink protocol to communicate with flight computer. So that was about Mavlink. So in order to connect flight computer to flight controller, we use a telemetry port. And for connections, you can refer this link. This is a documentation. So you can find how to connect your Pixhawk to flight computer. Maybe like you can see here, this is a Raspberry, and it's connected to telemetry port of Pixhawk, right? So yeah, moving on to next, there's SLAM. So SLAM stands for simultaneous localization and mapping. So it's a technology actually. It allows drone to build a map of its surrounding and find its own location at the same time. So as you can see here in this image, first it's what is happening is that this is the green map, and the yellow dot you see here, this is the drone which is covering that area, and it is using LiDAR sensors to generate a map of its surrounding. So that's an application of a SLAM. So now we know that when you are flying indoor, GPS won't work. So you need something now to guide your drone. So that's where SLAM comes in. Okay, so full form of SLAM, it was simultaneous localization and mapping. So localization, I'll explain about localization. So localization is basically getting the position of a drone. So you can say that you can actually see the drone and get its position, but that's not how drone will know, right? So localization, drone will know where it is right now. With SLAM, it will create a map, like it will generate a map of its surrounding. But with the localization, it will know where it is present at particular point of time. So these are the techniques which are used for localization. So first is GPS. Like we know there's a GPS module on the drone, and it receives signals from satellite. With the help of that, it locates itself on the Earth. Like it knows its position. But what about when you are flying in some environment where there are tall buildings and trees? At that time, GPS won't work, right? So at that time, we use these techniques like visual SLAM and inertial SLAM. So visual SLAM, it uses the onboard camera like monocular and RGBD camera to create a map of surrounding and find the location of a drone. And then the inertial SLAM, it uses IMU. So in inertial SLAM, actually it tells the drone where it is heading. Like I already told about IMU. So IMU generally, basically it measures the angular velocity and acceleration. So it tells the drone where it is moving and at what speed it is moving basically. And the third one is a LiDAR SLAM. It uses a LiDAR sensor present on your drone. It basically fires lasers in all direction, and then it calculates distance from the obstacles or so. So moving on, next, we have path planning. So now imagine you have autonomous drone, but it should know now, like where to go, what path to follow. that's where path planning comes in. So as you can see here in the diagram, you see there's this drone, and say this is the goal. Like we want our drone to reach here. So path planning is basically divided into two types. First is local methods, and another is global methods. So what in global method, what we do, we give the drone the map of its surrounding. Like say we gave a drone a map of its surrounding, then drone finds its path, like like best path to reach to the goal. Like you see here the red color line. This is the global path. And now consider like you have given the path, but while flying, the drone sees there's some obstacle on the path. So what drone does is that it like with now drone uses local methods. So with local methods, drone like it basically skips the obstacle and joins again. For local methods, it uses the sensors like lidar, say RGBD, etc., etc. So with the help of with those sensors, it basically uh, like it merges local method and global method to for path planning. So these two are the path planning algorithms. This is a Dijkstra algorithm. Okay. So what it does is these are like basically two algorithms which we use. So this is the start point and this is the end point. So with A star algorithm, it is like a little bit more efficient than Dijkstra algorithm. So it is used for global path planning. If you want to know more, you can join our aerial robotics course for that. So coming on to next, there's computer vision and machine learning. I guess most of you might be familiar with these words. So now, what we saw, like consider the same example of the flood rescue drone. So now, say it has reached the particular location which we have told him. So after reaching, it is like using cameras to capture the surrounding and locate the victim, right? So that's where the computer vision comes in. So computer vision, it gives drone the ability to see and understand the environment. And with the help of machine learning, it uses like the data to make decisions and all that. So next is the system architecture. So Ayush will be explaining about it.
Mm, hello, am I audible? Siddesh, am I audible?
Yeah, you're audible.
Hmm. So starting with system architecture. So you will be seeing three main parts. One of them is offboard computer, another is in मतलब जो onboard computer होता है that, and third one is Pixhawk, which is our flight controller. So starting with offboard computation. So offboard computation में क्या होता है? So for autonomous flights, like they said, integrating OpenCV and AI ML in drone, you use offboard computer to मतलब to train the models. Then you upload those models to onboard computer जो कि जेटिसन नैनो हो गया, और if you use इंटेल वाला. So it is for onboard processing. So ये क्या करता है, with this data sensors are connected to it. मतलब sensors like lidar हो गया and optical flow sensor हो गया, GPS हो गया, it is connected to onboard computer. So what onboard computer does is कि take data from all these sensors. Then जब ये data लेगा सब sensor से, what it does कि it processes the data and sends it to Pixhawk, which is flight controller. Like जैसे सिद्धेश ने कहा था, flight controller is driver without eyes, and our onboard computer is eyes. So eyes and brain. So what onboard computer does is take data from eyes, which are sensors, and process it like our brain, and sends the execution orders to flight controller. So flight controller क्या करता है? It sends the PWM signals या फिर PPM signals to ESC plus motors. आपको वो दिख रहा होगा नीचे ESC plus motor. So ESC पे signal जाता है. So what ESC does is to increase RPM of motor, so increase voltage. So मोटर के RPM वेरी करके it executes the maneuvers, going front हो गया या फिर going back or going left. So to execute maneuvers you use ESC. So basically it is very simple. Sensors onboard computer से connected होते हैं, and onboard computer processes the data, sends the data to Pixhawk, and Pixhawk converts the data to into maneuvers. And इससे मतलब अगर आपको मैनुअल कंट्रोल करना है तो यू कैन आल्सो रिसीवर विच इज डायरेक्टली कंट्रोलर टू योर ट्रांसमीटर. सो इससे क्या होता है, यू कैन कंट्रोल द ड्रोन मैनुअली विदाउट यूज ऑफ एनी सेंसर्स. एंड आल्सो मतलब जो किल स्विच होता है इट इज कनेक्टेड टू मेन पावर सप्लाई विच इज कनेक्टेड टू ईएससी, तो उससे डायरेक्ट किल स्विच भी होता है. सो मतलब दिस इज बेसिकली इतना ही सिस्टम आर्किटेक्चर इज दिस, नथिंग मोर देन दिस. सो मूविंग ऑन टू नेक्स्ट पार्ट, मैं आपको इसका वीडियो दिखाता हूँ. आई विल शो यू वीडियो एग्जीक्यूशन ऑफ दिस. सो सिद्धेश कैन यू प्ले द वीडियो? See, the guy in the video is taking the map of the area via using lidar sensors. These are big lidar sensors. So ये मैप करेगा and it sends the data to offboard computer, जो computer offboard होता है फिर which is your laptop. See, the thing is the computational takes lots of मतलब the processing of data takes lots of computational power. So to train the model, Jettison Nano is not enough to train the model. It is only enough to execute the maneuvers. Jettison Nano or RPI, which is onboard computer. So you use offboard computer to train the models. So he will send lidar data to offboard computer. See. So here it is drone. Drone has onboard computer and a flight controller like Pixhawk or any other flight controller. The joystick he is using, this is for basic commands like to take off and land. Now drone will be using sensors like optical flow sensors. The drone in the video is using optical flow sensor and lidar sensors. Now it will execute the maneuvers automatically. You can see here. It will avoid and here Siddesh, can you pause? Uh, Uh, yeah, here you can see the white lines. The white lines are possible paths. So these paths, the lidar sensor sends the 3D data to the onboard computer, and onboard computer sees possible paths. कि मतलब कहाँ पे जाना चाहिए, and it decides one of the path. The decision is made according to the model you have trained on offboard computer. So you can play the video, Siddesh. See, you can see drone is executing maneuvers automatically. White lines are possible paths, and it is taking one of those paths. See, it completed a rotation, it will be returning to its launching pad. You can see it is maneuvering automatically. Now he is using OpenCV for hand gestures. You can see here. The hand is being detected. You can see in the video. Now it is landing. See, for landing and launching, he is using controller because these maneuvers take lots of training because these are the crucial part. Your drone can be damaged, so it is easy to just control it manually. You can pause the video, Siddesh, and you can move on to slides. Can you do the previous one? That architecture. See, like he first trained the data and sent it to offboard computer. So where he trained his model. Then he uploaded the model to the onboard computer. जो कि उसका it had onboard computer. So what onboard computer did is take data from lidars and optical flow sensors and GPS and many other sensors. Indoor में GPS काम नहीं करता, but other sensors like accelerometer, gyroscope. So it processed the data, chose a path. You can see there are many white lines. So it chose one of them. So it chose the path according to the train model. Then it sent the data to the Pixhawk or flight controller, which was being used in that drone. So that executed the maneuvers like going front, adjusting altitude, adjusting roll, angle, and other things. So it is very simple. So moving on to next slides. How to configure your flight controller. So Siddesh will be explaining you. So Siddesh,
Okay,
you can
am I
explain.
audible?
Yes, you are.
So coming on to how to configure your flight controller. So first is Pilot. So Pilot, basically you can think of it as it is kind of a operating system for Pixhawk. So it is a firmware. Firmware is basically software which runs on hardware. So what Pilot, like they have their official website on which you can find different firmwares for different drone configurations. Like say you have a quadcopter and you have a hexacopter. So both of these will need different operating systems, right? So for that, you will choose the what do you say, firmware from Pilot, and then you will upload it onto Pixel. And how do we upload it? I'll tell you in the next slide. So now coming to Q ground control. So Q ground control is the software. This you download it on your laptop, and with this you can upload the firmware onto Pixhawk. Like you can calibrate all the sensors and all those things. So it also acts as a dashboard of your drone while it is flying. I said earlier that you connect a telemetry module and it sends the signal. So in the Q ground control, you can see all those details like altitude and speed of your drone and where it is moving, all those things. So basically, it acts as a remote control and dashboard for your drone. So before getting started with the QGC, I will just tell you what we have seen so far. So first we saw Pixhawk. Pixhawk was a flight controller. Then we moved on to Raspberry or flight. Sorry, Pixhawk was a flight controller. Then we moved on to Raspberry and NVIDIA Jetson Nano and all those. So these were flight computers or companion computers. So what flight controller is? Flight controller is Pixhawk. Basically, it controls the vehicle. And then we saw Ardupilot. Ardupilot is operating system for Pixhawk. It it is for Pixhawk, not flight controller. And for flight computer, there's a Raspberry and all those. For flight computer, there's a CV and ML and all those things. Now, what is Q ground control? It is a software which we use to configure the Pixhawk, and it is used for planning a mission. Say you want to execute some mission, like it involves taking off and going to particular area, survey that area, and come back. So for that, we use Q ground control. So basically, you download it on your laptop. I have given link later in the slides. Okay, so getting started with the QGC. So first you have to download it. Then this kind of interface will occur. Now you will click on the Q ground control icon and then go on to vehicle setup. So it will ask you to load the upgrade the firmware. So for that you have to carry out some basic steps like plugging in your battery and connecting Pixhawk to your laptop. So all those instructions are given in QGC. So make sure you use Ardupilot, not PX4. PX4 is also similar to Ardupilot, is also operating system, but Ardupilot is recommended. Now, after loading the firmware, you have to choose the airframe for airframe. So these are the airframes which are available. So depending upon your drone, you can choose suitable airframe for that. Now moving on to we'll move to sensors tab. So you have to calibrate all the sensors. Like there's a compass, accelerometer, all those sensors are there in the Pixhawk, and along with that there are external sensors like the GPS and all that. So you have to calibrate it. So for example, here you can see the compass calibration is going on. For that, it will ask you to place your vehicle and then rotate it along different axes. Next, we will go to radio section. So here you have to calibrate your transmitter. Before moving on to radio section, make sure that receiver is connected and transmitter is turned on and they are binded. So you will be asked to like rotate all the sticks and turn on and off all the channels. So later we will go to flight mode section. Here you will assign a channel for switching the flight modes. There are different flight modes available like altitude, acro, angle, and all that. You can explore the QGC to know more about it. And here you can assign channel to all the settings. Just make sure you assign some channel for arm switch. Like without it, you will get some warning and your drone won't start. So after the radio calibration, you will go to power. Here, this kind of interface will appear. So here you have to enter what battery you are using, what is its capacity, so that our Pixhawk should know how much power is left and all these things. So after that, you have to calibrate ESC. So for ESC calibration, it involves like plugging in battery like 2 or 3 times something. All those instructions will appear when you open QGC. So ESC calibration is a very important step, and in order to know whether it is completed or not, like the motors if calibration is successful, the motors will beep twice, followed by a single long beep. So you will hear a pattern like to know whether the calibration is successful or not. So after that, there are these other sections like safety tuning, camera, and all this. So these are set up by default. You don't have to do anything here. And one important thing is that in order to calibrate the compass and GPS, you have to be in an open area. As we saw before, that GPS won't receive the signals if you are surrounded by tall buildings or trees, etc., etc. So now moving on to mission planning. So I'll give a demo of a mission planning. So first you open Q ground control. Just a minute. Okay, so this kind of interface will occur. Right now it is showing disconnected because I haven't connected Pixhawk to my laptop. So like if you have connected a GPS module, it will show what is your exact position is on the screen, and lot more options will come here after connecting laptop to Pixhawk. So in order to plan your mission, you go on this flight plan thing. Then there you can see there are different like default things like blank. You want to create a blank plan, survey plan, or corridors plan. So for now, I'll show survey one. So click on the survey. Now you have to choose the takeoff location. So let's say we are going to take off our drone from here. Then done. Now altitude. So 50 meter is quite high. So we'll go with 15 meters. Say. Now next is survey. So these are the the patterns. So I'll go with circular. So you can see this kind of it is the area, the green color area. It is the area the drone will scan, and these white lines are the path followed by a drone. So you can adjust its size and all those things. You can also change altitude and spacing between the lines and all those things. And then after that, right now I'm not connected to Pixhawk. So when you connect it, then there will be option to load the mission into Pixhawk. So that was about flight planning. Depending upon your mission, you can also create a blank plan or all those things. So yeah, just a minute. Okay, so moving on to some common problems. So the first problem which might occur while making the drone is that GPS is not getting connected to Pixhawk. So you see, like this is the JPRC M1025 GPS module. So you can see the pin out. The first one is ground pin, second one is flight 5-volt pin, and then TXRX and followed by other pins. So on the if you see, this is the configuration of Pixhawk. In Pixhawk, the first one is a VCC and last one is a ground pin. So if you connect it directly, it won't connect. So what you have to do is you have to connect this ground to the last pin of the flight controller and 5-volt to the first, and then other pins followed by looking into configuration of Pixhawk, like pin out of a Pixhawk. So you can refer to this link to know layout of Pixhawk and also check what is pin out configuration of your GPS before connecting it. So another next is GPS signal not found. This occurs mainly because GPS requires to be in an open area, like away from tall buildings. So you have to be on the ground, and sometimes it might take more than 5 to 10 minutes. So have patience. Next is motors. They don't rotate. Like after calibrating ESCs, you go to motor tab and then you power up motors, but they won't rotate. So this mainly happens because of ESCs are not getting calibrated. ESCs are not calibrated properly. So what you do is you can calibrate the ESCs again, and if it doesn't work, then you can calibrate all the sensors again. So eventually it will work. So, one more important thing, like you can see here this diagram. This is actually a layout of a hexacopter frame from Pixhawk. So, as you saw before, there is a PWM breakout board on which you connect the motors. So there are numbers marked on it: 1, 2, 3, 4, 5, 6, 7, 8. So make sure you see this layout, which is available on Pixhawk's official site, and connect the motors accordingly. Otherwise, Pixhawk will think that if you connect this as 1, this 2, this 3, then the drone won't fly. It will just tip off immediately after takeoff. So that was all from my side. Now, Ayush will be explaining about INAV and all other things.
Siddesh,
Huh?
is my screen visible? Siddesh,
Yeah, it is
hello?
visible.
Yes,
Visible.
it's visible.
Yeah, visible now. Wait a minute. Hmm. So now you may have learned about Pixhawk. मतलब आपने Pixhawk के बारे में बहुत कुछ देखा होगा. So do you really need Pixhawk? क्योंकि because Pixhawk is very expensive. It starts from around 13K and इसका मतलब it goes to around 75K. There are different models of Pixhawk, Pixhawk Cube, and there are multiple models. So मतलब if you want to do simple project like मतलब simple एक autonomous drone बनाना, you don't need to add मतलब ML and उसमें AI वगैरह OpenCV नहीं डालना है. So is there any cheaper alternative? Yes, there is an alternative. So instead of using Pixhawk, what you can use, there are other flight controllers. So here you can see there are three types of flight controller I have shown. This PDB F405V3, which is most commonly used, but it is for quads. But if you want to make VTOL or airplanes, what you can do is use one of these two flight controllers. One is Matek H743W light flight controller, and another is SpeedWay F405N. So what are flight controllers? I will tell you again. In the world of drones, also known as UAVs, the flight controller is a different beast. You know, मतलब it is मतलब see, you can control a drone manually, but manually control करने से आपका autonomous तो नहीं हो पाएगा. If you want to do autonomous, तो उसके लिए flight controllers are there. मतलब इससे क्या होता है ना, ऑटोमेटिक स्टेबलाइजेशन मिलता है आपको, सब कुछ मिलता है. मतलब यू नो जैसे कि आपका मतलब यू सी पहले गियर्स यूज टू शिफ्ट मैन्युअली जो कार्स होते थे, आजकल क्या होता है ऑटोमेटिकली शिफ्ट होता है. वो क्यों यूज होता है? देर इज ऑनबोर्ड कंप्यूटर ऑन दैट कार. तो वैसे ही फ्लाइट के लिए देर इज अ फ्लाइट कंट्रोलर. So it's a circuit board packed with sensors, processors, and software that plays a critical role in keeping the drone stable and flying according to the pilot's command. So why to use flight controller? Flight controller uses sensors embedded in them to process data received from pilot or transmitter, and mainly the stability of your flying craft, drone even in a windy situation. It also provides the drone with an idea of 3D navigation for accurate detection of the drone's orientation, movement, and position. This data can be used to bring back drone to its initial position, जो कि है RTH function, return to home function, without actually driving, or can be programmed in a particular way to create a drone show and much more. Drone show देखा होगा. They use flight computers. फ्लाइट कंट्रोलर होते हैं वो यूज करते हैं. सो सेंसर्स क्या मैं आपको जैसे बताया होगा, दिस थ्री आर पार्ट ऑफ IMU, एक्सेलेरोमीटर, मैग्नेटोमीटर, बारोमीटर. देयर इज आल्सो एन पावर डिस्ट्रीब्यूशन बोर्ड एंड अ गायरोस्कोप. सो दिस इज PDB F405V3 फ्लाइट कंट्रोलर. इसके पार्ट्स तो मैंने आपको बता देता हूँ. इट इज STM32 बेस्ट फ्लाइट कंट्रोलर. सी यहाँ पे आपको बारोमीटर दिख रहा होगा. देयर इज इंटरनल बारोमीटर कनेक्टेड वाया आई स्क्वायर सी पोर्ट, and this is gyroscope. It is also connected by I2C port. And here you can see there are many USB-C port. It is serial interface. And see here you can see G. It is from ground. 5 volt is for giving the power. Here you can see R2 T2, T6 R6. What are these? These are UART ports. As I told you earlier, TX and RX. T is for TX and R is for RX. You can add मतलब receivers, GPS, anything to it, because it is UART. You can add any external sensor to it. So moving on to next part. हाँ, ये तो हो गया हार्डवेयर पार्ट. ना सॉफ्टवेयर पार्ट. So there are many softwares जैसे कि INAV, which I will be going to tell you now. Then clean flight हो गया, which is previous version of INAV, and beta flight and race flight and Ardu pilot. See, INAV and beta flight are almost similar flight controllers. I will tell you difference about them later. So, INAV, INAV is Navigation Enabled Flight Control Software. Its full form. It's an open source firmware specifically designed for flight controllers used in RC planes, drones, and even in RC cars. RC car में भी INAV use होता है because it is one of the मतलब easy software compared to Q ground control and Ardu pilot. Its interface is easy. So you will be asking why to use INAV, why not to use Betaflight? As I told you, Betaflight is similar to INAV. See, the difference between both is कि मतलब Betaflight is much focused on FPV racing and freestyle flying. जैसे freestyle वगैरह आपने देखा होगा, you may have seen many reels on Instagram and other. It does complex maneuvers. But for GPS flight mode and do autonomous navigation and having RTH function, return to home, you have to use INAV. Betaflight don't have RTH function because it's mainly based on manual operations. See, acro modes and other stuff. And INAV is mostly based on autonomous flight. So you can do detailed mission planning and execution. There are capability of INAV. In Betaflight, it's a high performance software, responsive and precision control. Since it allows detailed adjustments and fine tuning of PID settings. PID stands for power integration derivation. It changes the way your aircraft behaves on giving inputs. Also, INAV is easy to set mixtures of signal received and setting machines. INAV पे क्या कर सकते हो? You can do easy mixing. You can try multiple configuration. But in Betaflight, mostly you have to build quads. INAV में you can make VTOLs, fixed wings. But in Betaflight, you have to make only quads. And there is no option of mixing available. Also customization. So, more about INAV complexity. While INAV offers a lots of features, setting it up and configuring it might be more complex compared to simple flight controller softwares. INAV is easier compared to Q ground controller and R2 Pilot, but it's harder than Betaflight. Also, target audience. Who are target audience of INAV? INAV is generally geared towards more experienced RC pilots who want the benefits of GPS navigation and autonomous flight features. Learning resources. Here I have attached documentation for INAV. It have GitHub repository. You can check from there. Also, user interface. INAV has many useful features compact in a user-friendly software, and many free tutorials and documentation are available online. So I will be showing you installation and navigation of INAV. So uh, wait, I will show you how to install the INAV. Hmm. See, uh, to install INAV, you can go on Google and just search INAV. See, here you can see the GitHub link. So click on it. There are many files. You just have to scroll down. Mm, wait a minute. Releases. Oh, sorry, I went on wrong link. See, you have to go on second link, which is releases. Here you can find older versions and current versions of INAV. So the latest version is INAV 8.0.1. So how to download it? Just scroll down. Here you can see if you have Mac, you have to if you have Mac Intel version, you have to download Mac OS X64. If you have Mac ARM series, you can download Mac OS ARM64. Or if you have Windows, you have to download. If your computer is 32-bit, download the 32-bit version. If your computer is 64-bit, you can download the 64-bit version. Here you can see its file. Click on Show On. See here you can see there are Mac versions, Linux versions, and also Windows 32 or 64. I have Windows 64, so I installed the 64 version. After installing it, you will find a zip folder. You have to just extract it. After extracting it, you can see I know configurator, and you just have to you can see uh, a folder like this. Now click on I know configurator. See, this similar interface will be open. What you have to do is first go to Flash firmware, connect your flight controller. Actually, I was going to show you by connecting flight controller, but my flight controller just fried. So it matlab, short circuited. So I cannot show you the demo. So here, see, you can, I will just show you demonstration. What you can do is select your flight controller. Like we were using Speedway F405. So Speedway F405 V3. Then select firmware. You just have to select the latest one. Then just select load firmware online. See, the firmware has been loaded. Here you will find a simple file. Now you just have to click flash firmware. So the firmware will flash into your flight controller. So now what you have to do is control the flight controller. Now here you have to select the port. I am now selecting the demo and press on connect. Mm, see, you will see a similar interface after connecting your flight controller. See here you will see chord orientation of your chord. Whenever you will change the angular उसका axis change करोगे so it will demonstrate the changes in axis here. See this is main page. It is status. There are pre-arm checks like UAV is labeled after calibration, CPU load, navigation failsafe, many other things. So here it will show cell count. Currently it is not connected to anything, or either if you will be using 1S, it will show 4.2 volts. If you will be using 4S, it will show 14.8 volts, and many other data. So first, what you have to do is press on calibration tab. After pressing on calibration, you have to press calibrate accelerometer, and you have to just follow the steps. It will showing that press your chord on flat surface, move it to 90-degree roll or yaw. you just have to calibrate the accelerometer because it needs to be calibration. क्योंकि मतलब आप जब उसको किसी चीज पे रखो, इफ यू माउंट इट ऑन एरोप्लेन, उसका थोड़ा माउंटिंग अलग होगा, यू कैन मतलब थोड़ा एंगल पे माउंट हो जाएगा, या फिर इफ यू माउंट ऑन क्वाड कॉप्टर उसका ओरिएंटेशन अलग होगा. सो यू हैव टू कैलिब्रेट ईच टाइम. So here you can calibrate the accelerometer. Niche here you can see calibration of compass. You can calibrate the compass by clicking on calibrate compass. Now you just have to press save and reboot. After pressing save and reboot, it will restart the configurator. Every time you press save and reboot, it will restart this. So take note of this. Okay. So it just configured. Then there is mixer tab. See, you can do motor mixing like you are using tri rotor, other different types of configuration. See, you can press here. You can use quad plus, plus type configuration, or you can use Y6, which is a hexacopter with 6 motors. Or there are different types of configuration like Y4. There are 2 motors on front and 2 motors on back. So for counteracting the yaw motion created by single motor, you have to add another motor. So you have to select a Y4. According to your build, you can click here. So otherwise, if you click on VTEL quad, see, it is a VTEL quad. There are different types of quadcopter and planes. So I will just keep it on Y6 or normal quad. You just have to use quad X. Most of the time you will use quad X configuration. Plus configuration is rarely used because it had some problem while maneuvering. It will do naturally roll and yaw movement while doing one of those movements. So you have to use X movement for basic quadcopters. Then here there is platform type. I select from multi-rotor. There is also airplane, different types. See, it is a flying wing with differential thrust, airplane. See, there are multiple types of configuration. Tricopter, as I showed you, tricopter, or just we will keep it on multicopter mode. Then here there is mixing of motors. You can do mixing, and then there is servo motor mixer. If you are making VTOL, you have to also control the servos. So अगर आपका quad ऊपर जा रहा है, if you want to convert it into transcending motion, मतलब या फॉरवर्ड वाले मोशन में कन्वर्ट करते हैं, सो यू हैव टू रोटेट द मोटर्स इन फॉरवर्ड डायरेक्शन. सो इसमें क्या होता है, सर्वो का आप मिक्सिंग कर सकते हो यहाँ से. See, servo mixer, add new mixer, you can add logics, stabilize roll and other logic conditions. So it will mix the servo. For making VTOL, it is important. So moving on to the next tab, it is output. It is easy just for setting up motors. You can click here, I understand. And yeah, don't forget to remove propellers while testing it on ground. So you can increase the throttle of the motor or decrease it. Just for motor mixing, just configuring the motor. Then moving on to ports tab. See, on ports you will see UARTs. There are multiple number of UARTs. It depends on your model. SpeedV flight controller generally has 6 UARTs. Okay, SpeedV F4 or 5v3. So here there are, see, you can see many sensor options. You can connect sensor to UART like GPS, rangefinder is LiDAR or optical flow sensor. See, you can select here. Or you can also do like VTX. VTX means IRC tramp or TBS smart audio. It is term for VTX. Then ESC output, FR Sky, OSD or receiver. It is just for configuring the UARTs. As I told you earlier, I2C cannot be configured by us. It is mostly configured by the manufacturers. Then on moving on to configuration tab. Here you can see your accelerometer, other configuration. You can enable OSD. OSD means on-screen display. If you are using what we say FPV system, you have to check the cell voltage or other things. It will be visible on display. So you have to enable OSD. There are multiple modes. You can check according to your use. Like if you are using OLED, you can enable the OLED. There are multiple options. Here you can see battery voltage monitoring. So if you have battery voltage regulator, you can mount it on the drone and you can configure it from here. And there are many settings like number of cells, battery. It depends on your battery. If you are using 2 cell, you can check the voltage and change it to 2. Or if you are using 0, you can change it 0. It depends on you. You have to just change it here. It is for configuring everything. You can also configure the gimbal. If you are doing it for serving purposes or अपना ये हो गया क्या बोलते शूटिंग, यू हैव टू कॉन्फ़िगर द गिम्बल, जो यहाँ से हो जाता है. अदरवाइज इफ यू आर यूजिंग हेड ट्रैकर, यू कैन कॉन्फ़िगर इट फ्रॉम हियर. मूविंग ऑन टू नेक्स्ट स्टेप, इट इज वेरी इंपॉर्टेंट इन ऑटोनोमस फ्लाइट्स, दैट इज फेल सेफ. सी, अगर आपका ड्रोन उड़ रहा है एंड द मोमेंट इट लूजेस इट्स सिग्नल विथ इसका जो ट्रांसमीटर होता है फिर कंट्रोलर रेडियो होता है. सो व्हाट ड्रोन विल डू, देयर आर टू ऑप्शंस. वन इज ड्रॉप एंड अदर इज लैंड. सो उसमें क्या होगा, ड्रोन जहां से सिग्नल लॉस्ट किया, इफ यू डू ड्रॉप ऑप्शन, तो ड्रोन डायरेक्टली ड्रॉप हो जाएगा नीचे जमीन पे. एंड अदर ऑप्शन इज कि लैंड, इट विल ट्राई टू लैंड ऑटोमेटिकली. बट इट मोस्टली डिपेंड्स. सी, अगर आपके पास ऑप्टिकल फ्लो सेंसर है तो सही से लैंड कर पाएगा. बट यू जस्ट कैनॉट रिलाई ऑन बैरोमीटर्स, एंड 90% ऑफ फ्लाइट कंट्रोलर्स डोंट कमिट बैरोमीटर. सो इसमें ड्रॉप, सो इसमें लैंड करने का नीचे भी आ गया है ना आपका, नीचे प्रोपेलर्स विल डोंट टर्न ऑफ, बिकॉज योर quadcopter won't know कि मतलब वो नीचे आ चुका है. सो इट इज रिस्की ऑप्शन लैंडिंग. ऑल्सो ड्रॉपिंग इज ईजियर, बट ड्रॉपिंग में आपका क्वाड टूट सकता है. सो इट टोटली डिपेंड्स ऑन यू. आपको अगर रिस्क लेना है तो आप ड्रॉप वाला कर सकते हो. Even if you don't want to take risk and your quad has capability and नीचे कोई आदमी नहीं है, so you can just do land all option. And other thing is RTH. It will automatically trigger the return to home. See, अगर communication आपका break होते हैं तो automatically with the help of GPS, LiDAR and optical flow sensor, ड्रोन आपका वापस जहाँ से लॉन्च किया तो वहां पे वापस आ जाएगा. So इतना ही होता है. Then tuning tab. If you want to do PID tuning and other things, you can tinker here. Mostly इसे default पे रखना होता है. But if you're making something new, like VTOL and other things, you have to work on PID. So advanced tuning, you can look into it. Moving on to next part. And programming. See, it's a complex thing. You don't need it now. For PID, for people who want to explore with PID, can use this. Then moving on to receiver type. Here you have to select your receiver type. What type of receiver are you using? Mostly you will use serial receivers, which is connected to UART port. Like most of the time, currently the receiver most commonly the protocol used is ELRS, जो कि मतलब बहुत फेमस प्रोटोकॉल है, तो वही यूज करते हैं लोग. यूजर सेलेक्ट यहाँ पे, इट विल शो अप अ टैब, यहाँ पे शो करेगा जो अभी शो नहीं कर रहा बिकॉज वी डोंट हैव फ्लाइट कंट्रोलर कनेक्टेड. तो वहां से ये दिख जाएगा. सो यू कैन कॉन्फ़िगर द रिसीवर. देन देर आर मोड्स. आप अलग अलग मोड रख सकते हो. लाइक यू हैव टू आर्म. आर्म के लिए आपको ट्रांसमीटर पे मल्टीपल चैनल होते हैं. सो यू कैन कॉन्फ़िगर बटन, मतलब आर्म के लिए कौन सा बटन रखना है, प्री आर्म के लिए कौन सा. एंड फ्लाइट मोड अगर चेंज करना है, मोस्ट ऑफ द टाइम फॉर ऑटोनोमस फ्लाइट ड्रोन विल बी फ्लाइंग इन एंगल मोड. तो एक्रू मोड में आपको डालना है तो आपको ये सेट करना पड़ेगा यहाँ से. मतलब अलग अलग मोड्स, हॉराइजन मोड हो गया. देन यू कैन ऐड एल्टीट्यूड होल्ड वाला मोड. अगर इफ यू हैव ऑप्टिकल फ्लो सेंसर, यू कैन यूज एल्टीट्यूड होल्ड. मतलब बटन प्रेस करोगे तो ड्रोन क्या करेगा, एक एल्टीट्यूड पे रहेगा. लाइक हेडिंग होल्ड हो गया, टर्न असिस्ट हो गया. देयर इज मल्टीपल ऑप्शन. मतलब ओएसडी का हो गया, या फिर आरटीएस रिटर्न टू होम वाला बटन आपको सेट करना है, तो वो सब आप सेट कर सकते हो मोड्स वाले टैब से. देन एडजस्टमेंट वाला टैब की आपको अभी जरूरत नहीं है. इफ यू डू पीआईडी ट्यूनिंग, मतलब आपको अगर ट्रांसमीटर को आपको चेंज करना है चैनल्स वगैरह, तो उसके लिए ये काम में आता है. Then next one is GPS tab. It is just similar to Q ground control. आपको बस serial port होगा select करना है GPS के लिए. Then with the help of map, you can configure this. मतलब map की मदद से आप configure कर सकते हो. मतलब mission planner Q ground control में आपने कैसे किया था, वैसे you can use this. So it is easier. Then next is alignment tool. Here आपको आपका drone दिख रहा होगा. See, right now drone connected नहीं है. मतलब आपको अलाइन करना है. सी, इफ यू आर माउंटिंग फ्लाइट कंट्रोलर ऑन बैक साइड तो पीछे लगाना पड़ेगा. अदरवाइज यू कैन मूव दिस. जस्ट क्लिक ऑन दिस एंड मूव दिस. मतलब अगर आपके सेंटर में कनेक्टेड है आपका फ्लाइट कंट्रोलर, जिसे आप सेंटर में मूव कर देना. इट टोटली डिपेंड्स ऑन योर डिजाइन. आपका डिजाइन कैसा है, तो फ्लाइट कंट्रोलर को कहाँ पे माउंट करना है, आप ऐसे माउंट कर सकते हो. देन मिशन कंट्रोल वाला टैब हो गया. अगर आपको मिशन प्लानिंग करनी है तो आप ऐसे, इट इज जस्ट सिमिलर टू क्यू ग्राउंड कंट्रोल. जैसे वहां पे क्या है, आपको वैसे ही करना होगा. देन हो गया ओएसडी वाला टैब. इफ यू आर यूजिंग एफपीवी सिस्टम, तो यहाँ से आप ओएसडी वाला टैब करते हो. सो मतलब ओएसडी से क्या होता है कि मतलब आपके ऑन स्क्रीन डिस्प्ले पे क्या दिखना चाहिए तो वो दिख जाता है. वेट मिनट, आई एम हैविंग सम प्रॉब्लम. हाँ, सो ओएसडी वाला टैब हो गया. एलईडी स्टेप्स, देन सेंसर्स. जैसे हियर यू कैन सी सेंसर डेटा. इफ अभी तो वो कनेक्टेड नहीं है. इफ यू कनेक्ट एक्सलोमीटर, गायरोस्कोप, अदर, उसमें जो चेंजेस हो गया ना, तो यहाँ पे इट शोज ग्राफ फॉर सेंसर डेटा. देन इट इज, अभी तो इसका काम का नहीं है आपको. देन इफ यू आर यूजिंग ब्लैक बॉक्स, ब्लैक बॉक्स इज नेसेसरी इन ऑटोनोमस फ्लाइट, कि मतलब आपको पता चलेगा मतलब क्या क्या इस पे क्या क्या उसने एग्जीक्यूट किया है मैन्यूवर्स, या फिर व्हाट वाज इट एल्टीट्यूड. आपको रिकॉर्ड करना डेटा तो आप ब्लैक बॉक्स यूज कर सकते हो. एंड इफ यू वांट टू टिंकर सम डेटा, इट इज जस्ट लाइक कमांड प्रॉम्प्ट. इसका जो फ्लाइट कंट्रोलर का कमांड प्रॉम्प्ट होता है, तो फ्लाइट कंट्रोलर के कमांड प्रॉम्प्ट पे आप अलग डिफरेंट प्रॉम्प्ट्स डाल सकते हो। सी हियर मैंने जैसे प्रॉम्प्ट डाला RX रेंज, सो ऐसे मतलब यहाँ पे मल्टीपल प्रॉम्प्ट्स होते हैं। RX रेंज जो होता है इससे आप मतलब सी अगर आपका ट्रांसमीटर राइट को रोल करना पड़ा, आपको ड्रोन लेफ्ट को जा रहा है, सो आप यहाँ से RX रेंज चेंज कर सकते हो। तो ऐसे मल्टीपल कमांड्स है, सो यू कैन मल्टीपल कमांड्स, बस यही है। एंड हियर इन सर्च टैब आप सर्च कर सकते हो कि मतलब कौन सा फंक्शन चाहिए, कुछ चाहिए आपको, तो उसके लिए सर्च टैब है। बस बेसिकली यही है इसका लुक। सिंपल इसका जो वॉक थ्रू था मैंने आपको करा दिया है। नाउ यू कैन टिंकर इट, आपके इसके रिसोर्सेज अवेलेबल है यूट्यूब पे वगैरह, सो यू कैन यूज द रिसोर्सेज। एंड जब आपका सब कॉन्फ़िगर सेव करोगे तो यू हैव टू क्लिक डिस्कनेक्ट। अगर बिना डिस्कनेक्ट करे आपने यूएसबी निकाल दिया, समटाइम्स इट कैन गेट करप्टेड, सो इसके बारे में ध्यान रखना। तो बस दिस इज फ्रॉम माय साइड। थैंक यू। नाउ आई विल टेल Tanya to take over. Tanya, you can take over.
Before we end, a quick note on drone flying inside INSTI. Drone flying is banned till 3rd June. Check webmail for further update. Always have a first aid kit while flying. Propeller have to be put on at the last. The transmitter have to be switched on when plugging in the battery. Lipos are dangerous and have to be handled with care. Fly only over the area marked in the green in the following map. Maximum allowable altitude is 300 feet above mean sea level. A strict altitude restriction of 45 meters is put in place as IIT Bombay come under the active commercial airspace. Drone flights are permittable only between 7 a.m. to 6 p.m. Permission have to be taken from Airspace Department and from Harish sir. Night flying is strictly not allowed. Flying should be done only in the Gymkhana ground. Please make sure to go through them carefully. They are strict and must be followed at all times. If you have any question, feel free to raise your hand or type them in a chat. If you have any question, feel free to raise your hand or type them in a chat.